So
You
just to do a
legally
bit
have to
of
leave now.
intro for the recording, because my plan right now is to put these on YouTube almost as a podcast.
Mm.
And
Oh,
I
okay.
don't know if people will actually pick it up to listen for fun, but they might. So
At very
uh,
least, other people who want to join the group will be able to catch up.
exactly.
Mhm.
So we are currently reading Alien Oceans: The Search for Life in the Depths of Space by Kevin Peter Hand. This is the very first meeting of the book club. And previous to
Confetti
this
noises.
meeting, we read the entirety of part 1, Oceans Near and Far, including prologue, The Bottom, Ocean Worlds on Earth and Beyond, which is chapter 1, and chapter 2, The New Goldilocks. I'm Space Lord Ace.
I'm Rainbow
Everyone.
Shot 950.
I'm Try Too Hard for You.
And I'm Stealth Soft.
Great. Okay. There. Now, if anyone joins, they know who's talking and what we're talking about.
Let's go.
So, how overall, before we start into like the Google Docs and whatnot, what did everyone think of part 1?
Positive thoughts. Exclusively positive thoughts. Very
positive
fun.
thoughts.
Except for about the Ferris wheel.
Yeah, I mean, that was just like for some reason, that analogy like breaks my brain when I previously had a very solid understanding of what was going on. I felt like the Ferris wheel complicated things for me.
I agree with that because the Ferris wheel rotates, right? And so if you've got
Yeah.
things that are interlocking with specific other, like we're talking about electrons in this instance.
Yep.
Yeah, you did mention
If
that
those
it's
are
not
rotating,
a perfect analogy.
they would be breaking and reattaching all the time.
They're like
hydrogens and oxygens don't.
intersecting Ferris wheels sounds like the kind of thing that would happen in like an apocalypse movie.
I think it said nested Ferris wheels.
So there are nested Ferris wheels and there's interlocking Ferris wheels. So there's nested Ferris wheels that are the oxygen atom and the first two valence shells. But
Oh, see, are you guys thinking of like the Ferris wheels almost like opposing each other? Because I just kind of assumed a second Ferris wheel wasn't nested inside of it, but just kind of slapped to the side. So now instead of like 2 cars, there was 4 cars in a row.
So it's describing the oxygen atom as 2 Ferris wheels concentrically, and then the hydrogen atoms as additional separate third and fourth Ferris wheels on either side that are somehow sharing like fucking a Ferris wheel
they
car
share
going
the
around.
electrons. So like
there's a total of 4 Ferris wheels going on, and this is the part that broke my brain.
Yeah,
See,
that's
like,
where I feel like it fell apart for me too, because if there's a Ferris wheel on the outside of, let's say, the outer layer of the oxygen, and the hydrogen is also spinning, like their sides are rotating, and I don't know.
Yeah,
It
he
seems
did
difficult
mention
for me
it's
to
not a perfect
visualize.
analogy.
Yeah, he did.
see,
you know,
like, I
it's
thought the
not.
analogy was great, but now you guys are making it like more complicated than I guess I didn't
Yeah, like
think
diving
that hard
into
about it. Yeah.
Like I think we all understood the underlying principle, but like
Yeah,
I think I
if
was
you
just
don't
bothered.
understand the valence shells, say I.
Yeah.
I guess I kind of thought about it like, see, the oxygen atoms were wearing like, I don't fucking know, like purple shirts. And then somebody with an orange shirt that's a hydrogen atom decided to just like jump on, and they're like, hey, I'm your bud now. And they're like, great, nice to meet ya.
Like,
and that's like how I guess that's not what he
Alright.
described, but that's what my brain did.
I think
your brain
the issue for
filled
me
in
was
the blank.
the rotation. I feel like if all the Ferris wheels were broken, the analogy would be perfect because then they would be still. and
Yeah,
you
just
wouldn't
4
have,
broken
like,
Ferris wheels just
Yeah.
having a good time.
That's what I'm about.
Great. We love it. Just it's what a Ferris wheel looks like if you maybe just decided to like take some shrooms before you started looking at the Ferris wheel.
Oh boy.
It's kind of like a Ferris wheel, but also there's like some weird interactions between multiple Ferris wheels, and like I'm already uncomfortable with roller coasters. Like this sounds like a whole disaster.
Dude, I absolutely hate roller coasters, but I love Ferris wheels.
I'd
I've
just like
never
to
been on
Ferris
interject
either
and
wheels.
say
because I
that a Ferris
despise
wheel is
fun.
not a roller coaster.
You've never been on a Ferris wheel?
No.
Oh, it's so fun. They're
Sure.
not like fast or spooky like other.
Yeah, but we know this about me. I don't like fun, so
This is
Yeah,
true.
you should
Can
probably stay away
confirm.
from the Ferris wheels then.
delightful. Thank you. I appreciate the
All right.
Get that away
recommendation.
from me. I don't like that.
So, overall thoughts about like the amount that we read, the difficulty of what we read,
I thought it
anything
was
regarding pace?
at least for me, it was scaled perfectly. Like, it seemed like it was a good stopping point, which is, in my opinion, more important than like the amount of reading. Is like it felt like it was a pretty succinct like idea.
Yeah.
You know, there was something to talk about that we didn't cut off halfway through. Yeah.
Right. Yeah. So
I
thankfully,
think my good friend Kevin did a good job putting together this book.
What?
his good friend Kevin did a good job putting together this book.
Gotcha.
Yeah, as I trip over my words multiple times in the same sentence.
So on that note, then thankfully, all the pages I've given, they end at the chapter's end, and it seems like he's pretty good at like wrapping up even the individual chapters. So
Which is good,
Yeah, like the last paragraph is basically like a conclusion, which is very nice.
yeah.
yeah,
It gives you a little
Uh,
splash of what's coming too, which was
Mhm.
fun.
Yeah,
yeah,
for sure. I like wanted to continue reading.
yeah. That was one note I had. Like as far as like a nonfiction science heavy book, this is really well written. Like I was actively engaged reading it and didn't feel like I had to reread sections or like I was distracted. Like it was very engaging.
Yeah, and beyond being well written, he does the voicing of his own audiobook, which is
Yeah.
always a disaster, and he
Oh.
fucking killed it.
Oh, did
Oh,
he?
wow.
I
He did it
haven't
very,
listened
very
to any
well.
of it.
Yeah, like
I was actually telling Try Hard earlier that I had listened to it and then I went back to read certain passages that I wanted to see the text on, and I wanted to look at the diagrams as well. But I ended up just rereading the whole section because
Yeah,
it's engaging enough that I went through it twice.
very nice.
I
If
listened
there's
to
like
it twice as
one
well.
part of this whole thing that confused me. Let me see if I can find it. It's this diagram of the water particles. It's like figure D, and it's this
Yep.
like whole mass of stuff that I
Page
don't know what I'm
30.
looking at. Yeah, page
Oh,
30.
that
I
no matter how
should say
good you
page
get at
numbers.
science, that doesn't make any more sense. Don't worry. That's not you.
Talking
That's
about
I mean, those are like complicated fucking things to look at, even
yeah,
to an experienced person, is what I'm saying. Like those, there's no one that like really looks at. There's not many. I won't say there's no one. I would say there's not many people that look at that without several years of looking at something similar and understand immediately what's going on without lots of explanation.
yeah.
Oh, so from my understanding, that's the like the formation that water takes as it freezes, right?
Yeah,
That's
as
the
it freezes.
that's the crystal lattice that he talks about.
Yeah.
So that's like the building block that you'll see in a snowflake.
Yeah, and like the angle of how far apart, I think that's the hydrogen, how far apart the hydrogen is,
Mhm.
expands by like
the-
5 degrees.
Yeah,
And
that's
that 5
wild.
degree difference makes it so that it can float on top of water.
Mhm.
Indeed. All right. Let's just start going through the Google Docs then. And I think in the future, I was busy, like really busy today, but in the future, I'm gonna try and go through and take everyone's comments and like order them by page number. So then we can just kind
Yeah.
of go through in order. But this might
I
be a
think
bit of a clusterfuck because
We could also just thought about that better and just organize them by page number ourselves, as long as you put the page number at the beginning.
yeah, that's fair. I feel
Yeah,
like it's
page number
easier
at the
to
beginning
just
would be very nice.
yeah, let's do page number at the beginning then. We'll change that and then I would say leave the quotes not in page number order. Like I'll just look at them and reorder them myself because I want to keep people's numbers so that you can reference it and not have to worry about your number changing. So like if you look at quotes that we enjoyed, like Rado restarted at 1, 2, 3 for himself, which was a really smart idea in my opinion, because then if he references quote 1, we just know it's his. So then I can reorder those and still know what they're talking about, if that makes sense. Because I did that a lot in primarily the prologue. Like I just, instead of rewriting the just like, oh, hey, this is the second quote that I put down. All right, I guess, do you guys want to go through quotes and then go through the notes, or do we want to try and go through the notes and the quotes at the same time?
It's up to you, boss man.
Yeah, I would just say start at the top of the sheet and scroll down.
Scroll down.
That would be mine.
Yeah. All right. So the very first quote is one that I added, which is, "There's nothing in our Homo sapiens software that knows what to do when cooped up in a metal ball at the bottom of an ocean." And I just thought that was like a really great way to phrase that. This is on page 3, by the way, of the prologue. If anyone's following along.
It's a really
I don't
good
know.
way to connect. Also, a really good way to connect the like the bottom of the ocean with the space side of it as well.
Yeah, and I just thought it was really interesting to like say it that way. Like the best way of explaining like his confusion or awe was just being like, my body just had like no idea what to do with this. Like this is something that I did not know existed and had no concept of until I saw it. Which I feel like there's a lot of things like that.
It's definitely like a stimulus that your body just has no hope of processing. I feel like it's similar to like the concept of infinity or like stupidly large numbers. That's like, yeah, I've no concept of what that's like, and I have no way of even beginning to comprehend that.
Yeah. And I really liked that quote.
Yeah, I did as well. On a sort of related note, I'm pretty thalassophobic. Like the deep dark water frightens me a lot. And at one point, I decided I was going to try scuba diving, try to face your fears kind of situation. And I went 30 feet down, which is, I think, the furthest you're allowed to go down without further training or something like that.
Yeah.
Yeah.
And I related really strongly to the way he described how it's sort of serene, and you become kind of resigned to the fact that it's like, well, this is just sort of where I am now, and if I die, I die, which is probably not a great mindset, but I understood what he was trying to say there, which was really cool.
Yeah, it's not like any of those other tangible threats, like, that I'm being attacked by a lion.
Yeah,
It's
like being stabbed.
Yeah. It's just like, oh no, this is just like I am at peace because my brain doesn't even understand that it's in danger.
Yeah. While like logically thinking through it, you realize you're in danger, your sort of animal part of your brain is like, this is fine.
Yeah, I feel like
I
it's
think that's the crux
just
of it. It's like the instinctual part of your body that, or your brain, sorry, is that would react to impending threat, like a predator or like height that you might fall from. Can't really react because it doesn't have any context to relate to.
Yeah, I also feel like it has to do with like your body. Like normally where fight and flight situations are important are, I feel like most of the time, ones that you might actually be able to survive. But I feel like there's something about looking at the situation you're in and being like, wow, like if shit really went sideways, that's it. Like I'm done. There's nothing I can do about that. So might as well just be like, well, I'm here. Let's hope it doesn't. But if it does, like there's nothing I can do about it, which I think is like a really scary mindset, but also a very eye-opening one.
Yeah, definitely, thoroughly out of your
Strangely
control.
enough, I think like anytime you're in an airplane, it's basically the same thing. If something goes sideways, it's likely you won't survive. But
well,
for
at least
some
you
reason,
can
it doesn't
scream
have the same
then.
effect. Maybe that's it. Yeah.
At least you can scream.
Vocalize the existential terror at least.
My God.
I actually have nightmares about planes crashing.
Oh damn.
Like pretty frequently. It's one of the
Like,
reoccurring
are
ones
you
that
in the plane or is the plane crashing into you?
I'm in the plane.
Oh.
Like it's always like a commercial flight and I'm just in the plane. But the weird part is like there's that concept of like why drunk people and children survive car accidents more often is because they're relaxed. Like they don't tense up. And so I keep having these weird dreams where it's like instead of having like an extreme fight or flight response, the next like when I realize what's happening, I'm just like, I'm going to calm down as much as I possibly can and just pray that I am like calm enough and loose enough that I might actually survive.
Mm-hmm.
And
That's really
it's a really weird like because I have really realistic dreams, so it's a really weird sensation being like, I might die, but what am I going to do? I'm going to do deep breathing and try and relax every muscle in my body while I'm like plummeting towards the earth, which is like a really strange conclusion to come to, in my opinion.
That's really effectively internalized coping mechanism.
Yeah. Basically. All right. We're gonna move for time's sake. Move
Do we
on
have
from
do we have a
porn.
time limit on this? I guess that's a good question to ask.
I don't have anywhere I need to be,
Dope. Same.
so no, not at
I
all.
wonder if we'd want to have a time limit just for viewing sake for people who want to catch up.
Like
Yeah,
maybe, but
probably
I'd
keep
also
it
say like
shy of 3 hours.
yeah, like I don't want to cut short any important discussion.
Mhm.
Yeah.
Like if I find that people do really want to go back and watch this, I'll try and split it into like this is our discussion about the prologue, this is our
Yeah, have
discussion about
timestamps.
yeah, and be like if this is the part you want, but I feel like as long as we're engaged enough, someone listening will be engaged enough.
That's fair.
All right, so the next Rada kind of he quoted the words right before my quote. I just kind of took the end of it.
Mhm.
The next quote, which I actually wrote a comment about, says, "In retrospect, it should have been a simple decision. If you ever get the chance to go to the bottom of the ocean, take it. Don't think twice, just say yes. Your brain will be changed forever." And about that last part where he said, your brain will be changed to forever, I commented, I said, is this similar to like the overview effect that astronauts experience? But obviously, like, I don't know what you'd call it because it's not quite the same as the
The
overview effect.
underview effect.
Underview.
Yeah,
I
the
mean,
underview, like, just viewing something other than what you thought your conventional living experience was. Because a lot of astronauts talk about how that completely rewires their brain and how they think about politics and how they think about wars, and they're just looking at it and they're being like, why is this happening? Like, there's no boundaries here. And meanwhile, you're at the bottom of the ocean, you're looking around, and it's just like, this is where we live and fly planes over and our boats, and this exists like where we exist. And yeah, it's so different. It's so otherworldly, as he mentioned a couple of times.
yeah, Alien
I don't
Ocean.
want to poo-poo on the sentiment. I absolutely agree, but I think the separation between the two is scale. Like, for
Mhm.
example, like when you're down at the bottom of the ocean, your view is more limited than it is on the surface of the planet, like, or at sea level, I guess I should say. Whereas like when you're in
Mm,
orbit, you have a expanded view beyond what you're normally capable of seeing.
Yeah,
I guess that's how I interpreted it.
Yeah, I think I'm definitely on the same page there. I definitely interpret it much more as like this part of the world is so separate, it gives no fucks. There is nothing you could possibly do to affect this. It is like wholly separate, even though it is on the planet inhabited by humans.
right.
Yeah.
It's like it is entirely disconnected from you, even though it is, it's just out the window, right? It's like there are pieces of the world that humans have so little control over or access to. The world will continue with or without them.
Yes.
Mm,
I feel like
think that's
that's
right.
much more the direction that I took the quote, but I also definitely see with all the like connections he makes to outer space how you could find that to be more similar to like the overview effect.
yeah,
Well,
and
I
I
think you
wasn't
make
trying
the
to
right
say
point.
that it was exactly the overview effect, like it had the same effect on him, but
Mhm.
more like that kind of the more the like the world shattering part to a person, like
Yeah.
the
Okay.
wow, I'm in like kind of like you said, like I'm in so much control of every day of my life, and I think these really small things matter, and then suddenly you're presented with a reality that is just so utterly mind breaking that it's just terrifying, perhaps is the word. Yeah, not that it is exactly the overview effect, but similarly brain breaking or altering.
Mhm.
Yeah.
Yeah, I think I misinterpreted the comment then, because I absolutely see like what you're saying about like how this is like I don't know, an environment that is totally oblivious to anything that humans do, like beyond how important we think we are.
Mhm.
Like it's just not suitable for us, and there's no way we can
That's
impact
not
it.
changing. Yeah.
Yeah.
Yeah,
Mhm.
cool.
Yeah.
Does anyone have any comments between pages, basically up until page 8? Because we have some written ones here for page 8.
Most of my comments were on chapter 2, so.
Okay,
wait till
cool.
we get there.
I'm just like looking through what I highlighted here. One small one that I really liked was the basic physics of a submersible is pretty straightforward. One, don't get crushed, and two, make sure you can float when you need it. And I was just kind of laughing because that's, in my experience in engineering in school, how it all is. It's like, well, it's really simple. Like airplane wings, really simple. Just like have more pressure on the bottom than you have on the top. And it's like, okay, but like, sure, it's really that simple.
Yeah.
Yeah, but I would
Well,
offer
like, go ahead.
the concept of don't get crushed and be able to drop the heavy weight is way like, you know, anybody can make that. You might not be able to make a great one, but like you can over engineer a submarine into the point where I could make a submarine that goes to 7,000 feet. I'd make the walls 3 miles thick,
My God.
and you know, like just be able to drop the weight at the end, and you'd be good to go. Like it is.
Wait,
I
how'd
feel
you
like
get in?
Take the elevator.
you'd run 3 miles, obviously.
Duh.
How would you drop it in the ocean? Wait, are you rolling this thing?
No, you're
It
building it
doesn't
in the
have
ocean,
to
Rainbow. God damn
But
it.
you're building it in the ocean, right?
Right, yeah, you just build it in the shallow part, obviously.
Great.
Like,
Great.
this information isn't really relevant, but the idea of pressure pushing into a sphere or a circle got me thinking about keystones, like used in like stone arches in the ancient past, or in any
Oh,
building
yeah.
they build now with arches, and how you can
Alright.
use you use gravity obviously to hold everything together, and the keystone holds it all together.
Mhm.
You could build a sphere out of keystones if you had pressure coming from every direction.
And
And how
I think that's generally the concept that they use of that's why, you know, super deep sea submersibles are as close to as they can get to a cylinder or a sphere, sorry.
Yeah.
So that all of the pressure is directed around the object versus directly through it.
Yeah.
Yeah, and I just found it was funny how untranslatable that is to the vacuum, because all of your pressure is going the wrong direction, and you
It's
can't
the
build
opposite.
a reverse keystone.
Yeah.
There's just no
It's
way
like,
to
keep
do
it
it.
in! Keep it in!
Yeah.
Yeah. It's definitely funny to hear, like, comprehend how, like, I understand that all of engineering, oh yeah, that's really simple, just don't let your building fall over and you're fine. But like I think there's a lot more that goes
I
into
should have been
don't
an
let your
engineer.
building fall over than there is to, you know, make sure you can let go of the weight when you get to the bottom.
Well, I'm just thinking, like, if we're talking about if I really tried to make, like, say I set out on a project to make a submarine, like, that is the basic, like, let go of the weight, but you have to look at, like, material science and, like, how long is this gonna be under stress for? Do we want to reuse it? Like, that will change the
Mhm.
like, what you put on the submersible, not spacecraft. My brain
Yeah.
is wired the other way
We'll get
around,
there.
but, like
Calm down.
yeah. Like, what material am I gonna use? You know, do I wanna try and use a lighter material to ship it there so I can pick up a heavier weight when we get there, or does a heavier weight cost more? Corrosion factors. You know, you have to have batteries on there, power on board. Is it really sealed?
For sure.
It's suddenly, like, a lot more, and I just think I really love when people just state things so simply like that. It's like, "Well, yeah, it's just like this," and you're like, "Fuck off."
Just do the thing. It's so easy.
Reminds me of
I'd
you know what it
say
reminds me of? Engineering professors. Just do the thing, it's easy, and I'm like, "I get that you've been doing this for, like, 40 years, but I haven't."
Yeah.
The way he described that submersible, there's something so endearingly Russian about it.
Yeah, what do you do?
Yeah.
What do you do if shit goes bad? You grab the big wrench. Fuck yeah. Yes, you do. You definitely grab the big wrench.
Sounds like a
the part
fucking
that
game
stressed
of
me out,
Clue.
the part that stressed me out so much was him saying that like, I don't know if the wrench is there. You know, the thing that could save us so that we don't die.
It's alright, he had, like, 4 Russians, they're strong grip. It's the
Oh
same
my
as the
God.
wrench.
They would
there was
turn their
3 of
hands
them down
into
there.
wrenches.
I'm sure they could MacGyver a wrench if they needed one.
Something else that I thought of while we were talking about this was the concept of if you want, let's say you decided you were going to do a trip to Europa, a manned trip to Europa, and you wanted to have a submarine. You could like, I really like this idea of like amphibious vehicles that you can ride them on land and in water. You would need to completely redesign whatever you had to get there. Like you couldn't just translate a rocket ship into a submersible because the demands are so wildly different. So you'd need to
They're
have
literally opposite.
they're
Yeah.
literally opposite, which gives you this really funny engineering problem of you need to build a rocket ship or a spacecraft of some fashion that can take you and your submarine there, because you cannot repurpose that spacecraft into a submarine. It just
Yeah.
it is wholly different.
Like
I
my
mean,
immediate thought would
give
be
an
making it
engineer
like a
that
Russian nesting doll.
Yeah,
for
exactly.
Aquaman. Yeah,
What
like
if you just like put a rocket, like put an engine on like a submarine and just have it blast over to Europa?
Yeah.
it would not survive because like the
I mean,
materials there
we're
are
even
made
forgetting
for.
that you're eventually going to have to like create an opening in the shell of the ice.
Yeah, you're gonna have to drill like a
I assume
founder.
that's what the rocket was for. You were just gonna rocket straight through it.
No, absolutely
Yeah,
not.
Sure.
I myself
I
am
am
in
sure.
Minnesotan, and we build a lot of bonfires on a
I mean, it's
lot
only a
of
few
lakes,
kilometers thick, I think.
and you cannot
Um,
use fire to melt through ice.
No, it'd probably be a laser. Like a laser
As
would
maybe
probably melt
you've
through
read
the
in the
ice.
book, water and
Or
ice are insulators. and they
Uh-huh.
I
transfer
bet you
heat
I know what it
really
would be. Just make a insulating like Russian nesting doll around like the actual submersible itself, right? Like that
Uh-huh.
keeps it safe from the heat from travel because submarines are made for insulation, like keeping warm in, like holding warm, not getting warm, which is the
Mhm.
opposite of a lot of like vehicles. But just use like some remember like the Martian? Remember how he used that nuclear core to like keep him warm?
Yeah.
You just drop that on the ice. Just let it slowly drill a hole, and then just like your submarine should be a circle anyways. Just roll into the hole. It'll be fine.
It'll be fine.
But ice is such an effective insulator that
Wait.
your hull will be the diameter of whatever hot object you drop on
Oh,
it.
That's true.
Right, that's what I'm saying. But it would have to be the outside of the Russian nesting doll that would have the nuclear warmth, right? So it would automatically be larger than the submarine that's in the very center.
Perfect.
You're slowing down your drilling process. Every time you get bigger, it's slowing it down.
So
It's
here,
well,
guys,
I mean,
guys,
it
I
already
read an
takes
Elon
like
Musk
6
tweet
years to
about this
get
once.
there.
Guys, Elon Musk already has the answer. We just
Oh,
nuke
fuck
it.
Oh dear
It's that
God!
simple.
yeah. Don't we just terraform it?
Looking for life on another planet, nuke it. They'll be fine.
Yeah, we just nuke our way through the ice shell and call it a day.
I'm
Oh,
sure
weird.
they're
There was life here,
radioactively
but now it's all
resistant.
irradiated and dead. I wonder how that happened.
Yeah, like
It seems like a
organisms that
catastrophe.
have dealt with almost zero radiation their entire life, they'll be okay. All right. Moving on.
All right.
We could go off on this all day.
Tangent complete.
My next highlighted thing was just learning about the fact that there's a part of the ocean called the photic zone.
Mhm.
I really
Yeah, where they're
appreciated that
actually
there was
light.
like a name for it. I was like, I like this. This is satisfying. That's all. I literally just
Yeah.
wrote makes sense.
Yeah. I also,
All right.
I think I was like cursorily aware of the fact that, like, in the Challenger Deeps or the Marianas Trench, like there are animals living at the thermal vents. It just never occurred
Yeah.
to me that they don't exist in the same food chain as we do.
Oh yeah,
Right?
Every
Yeah.
single other organism.
Yeah, they're just so far removed from us.
Well, but
It-
they're metabolizing like
Yeah,
elements,
chemicals.
which is so bizarre to think about.
Yeah.
Yeah, chemosynthesis versus photosynthesis are wholly different food chains. And beyond that, there's even like sort of a what isn't truly a third food chain, but there's another separate like food source in marine biology that is just detrivores. So basically things that live in sections of the ocean that are too deep for light to reach, but they feed exclusively on waste dropped by things that live in the photic zone. So whether that's, a whale carcass that dies and falls, or it's literally just the excretion of other things.
So wouldn't that
built
be
almost like an
included in the
underwater
food
fungus.
chain of the whatchamacallit, the photosynthetic zone?
It's technically part of the photosynthetic zone, but it's only it's unidirectional, if that makes sense.
Right.
It
No,
offers it offers no energy back to those organisms that exist up there.
Well, that's not
I guess it's kind of
entirely
self-containing.
true. That's not entirely true. It just offers energy back in a really like not immediate loop, right? Because those organisms eventually die and decay, and what they
Mhm.
do is release gases, and those gases eventually float back up, which are eventually absorbed by plants, and then those plants get eaten by animals, and then some of those animals are eaten by seafaring animals, and then some of those seafaring animals are then
In
eaten by larger animals.
in
Like,
most
it's
cases, the
long.
nutrients are not going to move up in that water
No, the
column.
nutrients won't, I guess, but
Well,
energy does.
not in any significant way that you could connect via food chain, but yes.
Not via food chain. No, not via
Yeah.
food chain. I was just being a dick. Like, technically, long term, that energy does make it back around.
Technically, the Earth isn't a closed system, right? Yes, I agree.
Yeah.
Somebody find that picture of the guy with the word "actually" under it.
Actually.
Actually, right.
WK.
Uh-huh.
All right. Moving on, if that's all right.
No.
Well, too bad. The next quote, which I also wrote a comment for, which Rada also quoted, which I think in the future we should double check that the quote's not already there, and if it is there, just write like you second this or something.
Hmm.
Like, oh yes, I also read this and I also really enjoyed this and was going to write it myself, but basically just put like sign your name behind it or something of the
Yeah,
sort.
hit him with a plus sign or something.
Yeah, exactly. The quote is, "Water, the key ingredient to life as we know it, turns out to be very good at hiding much of our own planet from us." And I commented, I said, "It's interesting that perhaps the best resource for life is also one of the best methods to hide life from us. It's almost too perfect that is the case."
Hmm.
It's
Yeah.
it's like one of those things that you're just like, man, it's like one of those special cases where you're like, well, it's not really that special, but at the same time, you're like, how poetic.
Yeah, it's super interesting. I think it's like, there's this commonly quoted statistic or like fact in marine biology that we have better maps of the surface of Mars than we do of our own oceans. Like,
Yeah.
and
Can confirm our detailed maps of Mars are detailed.
yeah, and it's like it's kind of wild to think of how much information is hidden there.
I think it's like 90% of fish we just don't know about.
Well, he
There,
touches on that in the prologue. He talks about how it's impossible for basically any technology we have to really penetrate any significant depth of
I think
water.
Yeah.
this is the same section we're talking about here, where it's like, yeah, there's radio waves, Wi-Fi, 4G, none of that. None of it goes anywhere in water.
Has
I
anyone
think
ever tried like scooping it all up and seeing what's in there?
So there are these really cool things called sponge blocks in Minecraft, and I think we could probably just
Whoa,
soak it all up.
Wait, how many square meters does a sponge take up?
I think
I mean, it
it's
One by
depends on the
one.
size of the sponge.
yeah, the sponge is one by
block
one,
is
but
1 meter.
right, but it does a 5 by 5 area. So like,
5 by 5. That's
Oh.
25 square. That's 25 cubic meters.
yeah,
How
that's
many
pretty
cubic meters
good.
is the ocean?
I don't know,
Okay.
some.
Cubic.
And
You
and
know
you know what we
the
could do?
Meters.
We could just pile a bunch of sand in 1 meter wide walls around the whole area.
Oh my god.
See, I
I
think really
appreciate what you're trying to do, but I can't endorse this experiment.
I can't. Yeah, please don't. But like when it comes to like water hiding stuff, I even think about, like when I go to one of my favorite places, Lake Powell, and I'm dipping my feet in the water. Wow, English. Like I can see my toes, sure, but there could be a fish another foot below me, and I would have no fucking idea. And like I think about how long we've had like the fish meters for fishing, that'll tell you the size and where the fish is, like the depth, and
Mhm,
how fucking inaccurate those are.
mhm. The
Like it's
little sonar blips, yeah.
yeah, it's truly
They're called
wild in my
flashers.
opinion, like how good it actually is. Because here we're talking about like oceans deep, and I'm like, not like this lake, like 20 feet. That's too much. I have no idea what's down there. That's like, I'm not sure I want to know. Like there could be a dead body down there. I'd have no idea.
Yeah, it's like talking about $1 million versus $1 trillion. Like, yes, $1 million is a lot of money. Also, $1 trillion is a lot of money, but my brain has no way to understand the difference between those.
Mhm.
Yeah, it's just like it's so true, but I had never really thought about it that way. I'm like, wow, yeah, we really have like it is a common thing. I'll say like yeah, jump in that water. You have no idea if you're swimming over a dead body. Like if I want to freak my friends out or something, you'd be like, there could be someone dead down there. You'd have no idea. Like,
So, being from
ugh.
Minnesota, the land of 10,000 lakes, as it's
Oh,
Oh
of
my,
course.
he's an expert.
yes, I know all about lakes. There's a lot of different things that contribute to the clarity of water
Mhm.
in lakes,
Mhm.
and there are lakes like straight spring water that are absolutely clarity clear down to 30, 35 feet here, you know.
Mm-hmm.
Oh
And
wow.
so it's a matter of what is in the water that really affects the I guess penetratability of it.
Yeah, I guess there's also something to be said that the life that water harbors, it can sometimes be a huge contributor to why it is so difficult to look through.
I think
Yeah,
it's
like the phytoplankton is often. It turns out photosynthetic life is designed to absorb light, which makes it really hard for that light to get any deeper.
and I think a lot of
Exactly.
times it's the decomposition of the life that lived in that body of water that contributes to its
Absolutely.
clarity.
Absolutely, the sediments and various organic matter that like is suspended in the water definitely plays like a very large component of that clarity factor.
Yeah.
Yeah. All right. The next thing, this is just like a little comment I made because, in case you guys know, I really like space. He said a few of these worlds, Europa, Enceladus, and Titan, could be even hospitable to life as we know it. And I was just really taken aback by that the first time I was reading this book, because I feel like the only two I personally ever hear about, especially in like the spacecraft community, is Titan and Europa. Like the two that we're like, we want to go to and search for life is Titan and Europa. This is the first time, at least, that I've noticed or remember having Enceladus mentioned there, which
This is actually a question I
really
wanted to ask.
interesting.
How recently was the idea of title? I'm sorry if I'm getting ahead of
He
the gun
mentions
here.
the paper. He mentions the papers that say talk about Europa and whatever, right?
I think let me look here. Title heating.
I seem to remember something about that.
But yeah,
Because I agree, space with the concept that I only ever heard about, like the oceans on Titan and the ocean on Europa. But
Yeah.
Yeah, I think it's more of a matter like this guy is going into stuff about like, yeah, we think that like the sort of Goldilocks zone of these places being habitable for life because of this heat and stuff. So they're going basically like the limits of where habitable life can be sustained. So that's why they're considering places like I can't pronounce it.
Europa,
You
Enceladus, and Titan.
Enceladus.
Enceladus, yeah.
Places that I think they mention, I might be confusing this, but they mentioned that like it could have ice on the floor, which would make it probably not able to
yeah,
sustain
they talked
life.
about Callisto, that it might be too large for that.
Yeah.
Yeah, too large
that was
because
a
of
lot
like
of
the
stuff that
gravity of
was
it.
brand new to me. The concept that you need a rocky ocean floor
Yeah, I learned a lot of
Yeah,
stuff
as
that
reading
opposed to
this.
just more ice.
Of note too, talking about this, like I know Titan was always mentioned, but not for the reasons like he gave here. The like offhand reason I'd always hear from professors and whatnot is like, well, we know methane is like a commonly organic compound, and there's methane lakes, and so he was like, we're gonna look for like water-based life. I also hear a lot of scientists just remark, well, there's very well that it could just be like methane-based life hanging out on
Yeah.
Titan. And then to also build off that, I don't know if you guys were aware, but this last it was April, maybe perhaps. It was this like last school semester. A new mission to Titan actually got approved by NASA. It was
Oh yeah, I saw that.
$30 million deal, something like that. It's called Dragonfly. It's supposed to launch in April 2026, and it will arrive at Titan ideally by December of 2034.
Oh wow.
and it's a helicopter. It's a quadcopter, actually. It's huge. It's a huge quadcopter, which is actually really easy to do on Titan because there's a really thick atmosphere there. It's unlike Mars, where it's like, if we get something to fly on Mars, that'll be huge. Whereas on Titan, it's like, if you don't get something to fly on Titan, you're dumb. Like,
Wait, how does
it's
a
really
quadcopter
easy.
work in space?
It's not a quadcopter the whole way there. It's a
Oh.
rocket and it lands and then it's a
Okay.
quadcopter.
But it's
That's a really fun
whole,
visual, though.
yeah, its whole
Quadcopter
plan, its whole
streaking through
scientific,
space.
yeah, its whole scientific goal is to study prebiotic chemistry, and extraterrestrial habitability at various locations. And the perks of this is, whereas on like Mars, we have rovers and whatnot, and they make it, I don't remember what the max distance is covered by rover. It's not a lot, in short. But Dragonfly can just kind of just pop up and fly wherever the fuck you'd like to.
Yeah.
I was actually wondering about this. Like, obviously, it's a great idea, but is it? I feel like it might be better to have numerous smaller vehicles.
I think it
because you might run
depends.
into a failure, and if you've got 7 small vehicles, you'll at least have a couple that work.
Well, oh, go ahead.
I'm sure Ace will speak to this, but like, I think part of the way they design rovers is to maximize the amount of instruments they will have working at a time, and I think that's a lot easier to do on a larger machine than it is on a smaller machine. And pardon?
Is that power management, or is there other reasoning?
This is just
the
what I've seen
science.
on standard rovers.
It's when you get down to that, it's like the amount of science you can do. So if you send out like a whole bunch of tiny ones, maybe you'd be able to take pictures, but you're gonna want things on there like a small drill, a shovel, you're gonna want something that can do spectroscopy, gas analysis, maybe analysis of methane counts, hydrogen counts, like, and you want to be able to do that. And if you were to do 7 small ones, you'd get almost no science done, maybe other than some pictures. And that's to think that, especially out at Titan, that a smaller vehicle would even be big enough to be able to relay those images back to Earth. So it comes down to if we're going to send something that's going to take how many years? It takes off in 2026 and doesn't get there till 2034. So if we're going to send something that takes 8 years to get to its destination, you're going to want to pack as much science as possible to, hopefully for a while subside the urge to just already send another mission, i.e. Mars is a great example, but it's closer, so it's easier to send another mission.
Yeah, you see, this is why you ask questions.
Exactly.
And I think another big piece of that is, sure, you could have one of each of those instruments on your 7 different rovers, but you're going to want them in the same place so that you're getting, if you're, using a shovel, you have a drill and a shovel and a, whatever else, a spectroscopy unit, like these things, you're going to want to test all of the same material. So by having them all in one place on one rover, you're saving yourself trying to coordinate having 7 different rovers test the same spot.
Yeah.
Also, it's not like it's the first like rover or anything that's been sent. If it was like one of the first, then it's like, oh well, like 50% of them blow up, so we should send like 2. But now it's been more refined over time, I suppose. I don't have any specific knowledge of this.
As you're all burning me up for my comment, I'm
we're
also
not.
reflecting on the fact that also, like, there's a lot of radiation and different pressures that are affecting these things that you have to take into account.
Yeah, you definitely want to build them to be sturdy.
Exactly.
Yeah, like if you're ever wondering why we know so little about the surface of Venus, it's because one craft has landed and it melted in an hour.
Yeah, that was a Russian craft, wasn't it? I've seen those pictures, and for some reason they make me very, very uncomfortable.
Yeah, those pictures are scary. Like, they send goosebumps down my spine. But no, I didn't mean to flame you. I mean, these are questions I once had, and I just so happened to ask the people who actually make these things. So it's easy for me to relay this information back to you.
And I think the
Yeah.
idea of having 7 mini rovers is like very intuitive. Like that
Well,
makes so much sense.
I wasn't
Yeah.
talking about rovers. I was more
Right.
talking about the
The copters.
drones. Yeah.
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 Just relaying.
It's not a bad idea, like if they wanted to map out or something. That's like it's really intuitive. Like
I think that's probably where I was going with it.
yeah. And then Rainbow, to your comment too. Yeah, like the thought to send to, you know, like we learned our lessons with the what was it, Mars Climate Orbiter, where they didn't convert units, so it crashed. It's interesting when you start looking at statistics of like who makes the spacecraft and if it lands or not. Like the United States and NASA have a really, really high success rate. But other organizations, you know, that haven't had a long-standing space industry to begin with, especially when this started as a political race, like this information is not really, a lot of it is not public information, particularly the engineering information. So you have a lot of people starting almost on the same knowledge that we had when we decided to go to like the moon the first time, and our knowledge of how to land things there. And then when you build these spacecrafts, you sign like NDAs. So these other countries have like no information, and so they have like a 60% chance of crashing, like not making it and doing what they want. But then if you look at like US standards, it's like a 1% chance that it fails, unless you're the James Webb Telescope. But that's a whole nother rant.
Check W.
Keck W. It's really interesting though, like when you look at this is a whole other just like kind of kerfuffle about space. But it's really interesting when you look at it that way, that you know, space is so, even though it's public and it's government funded, it's so private. Like Mars, one of the Mars rovers detected methane once on Mars, which would have been, if they can confirm it, it's huge. And the reason, while we're talking about life on other worlds, is because methane is almost rarely, it's very, very rarely inorganically made. Methane is almost 100%. Oh my goodness, that was loud.
It's rarely inorganically made in the inner solar system.
In the inner solar system. In the inner solar system. Like if we found methane on Mars, that would be a huge indicator that it's outgassing from things that had previously died, or some sort of plant life or something like that. And people were like, well, no, the rover was just contaminated. It came from Earth. And we're so fucking secretive about how we build shit. They wouldn't release the cleaning process. They were like, no, trust us. It was like clean. And people are like, well, show us it was clean. And they're like, no, we're not telling you. So that was
clean,
sorry,
but
that
I
was a whole
farted just
rant.
as it launched. So.
Yeah.
Right, exactly.
Jesus Christ.
I mean, that's pretty much how that works.
If you guys want an update, the reason they originally thought it was contamination is because it started, like, the count started really strong, went down low, but none of the orbiters could confirm it or saw it. So maybe it was like super special and localized, and they were like, nah, it had to have been contamination. But it recently started up again.
Mm-hmm.
Which, if it was contamination, unlikely. It's a whole, that we could have a whole fucking podcast about methane on Mars, and I could go into it.
See, I
Yeah,
thought
you're the Mars expert here.
I was thinking that the reason it was high and then dipped was because something was stirred up or disturbed by the landing.
Mm-hmm.
Right. It's interesting because we haven't seen it anywhere else. So even if it is coming from Mars, it poses a really strange question. Like, did we just win the lottery? Like, how come we haven't seen? How come the satellites can't see it? Like, is it that fucking small of a space, like that small of a region, that like the resolution on satellites isn't enough to see it, which means it's super special? And like, why Gale Crater? Like, why is it there? Is it there? Like, which is why people are like, oh, it's just the rover. And people are like, but I don't think it is just the rover. But then people are go, then what the fuck is it? And everyone's like, I don't know.
Mm-hmm.
So yeah, that's a whole kerfuffle, a whole one might say a scandal almost, but it's not quite a scandal because nothing's been proven. Just like if you have a whole bunch of Mars scientists in the room, just be like, so methane on Mars, if you want the conversation to get real fucking interesting real fast.
Mm-hmm.
All right, sorry. Wow, full divergence there. It's
Mhm.
okay. Sorry, my bad.
Yeah, no worries.
That's why
I-
we're doing it.
Yeah, I
Yeah,
hope it was
We're
interesting.
here to talk about science. Remember?
Yeah, I hope my rant was interesting.
It was.
Thanks. Okay, so that concludes the prologue. We are now officially on to chapter 1. I'm looking for the next comment made there, which I think is just the first comment I made. It's all about me. Everyone get wrecked. Um, oh, Bretta commented about this a couple times. Basically about the question about looking for life. So there's a comment he makes on page 12 that says, thus, as we search for life elsewhere in our solar system, we are primarily searching for places where liquid water can be found today or where it might have existed in the past. And like the reason that we do that, if you guys, I don't know if you guys were questioning why we do that, but I don't know if you guys listen to the podcast. I'm just taking this straight from the author himself and how he was talking about, like we are sending instruments to hopefully detect other forms of life, but it's really hard to prepare for something that you don't know what it'll look like. And like if we had the money, we would, but we don't. So we do what we know.
Yeah.
And I just thought that was like an interesting point he made in the podcast and in the book. Is it's just
Yeah.
like we do want to look for other life, but we don't know what that looks like.
Yeah, the
We know
whole concept of life with weird chemistry, as he was calling it, which was
Yeah.
non-carbon based life,
I
is
appreciated
absolutely wild.
Yeah, like I think I posed something in chapter 2 about that, which we'll get to later. But yeah, that conversation definitely continues through chapter 2. But that was just a
that. I mean,
small note I had.
ultimately, all science is like very human centric.
Yeah, because it's trying to understand our world and our existence as we know it, and we're not very good at doing much else.
Well, and we're
Um,
looking through the lens that we can see through.
Yeah.
Exactly. It's kind of like we know there's fourth and fifth dimensions mathematically, but can we even see them? No, we can't, because we live in a three-dimensional world, and how are we supposed to, other than mathematically, comprehend that?
I don't know that.
You don't know that?
No. I don't know.
It's a very strange thought. Like, I don't
Yeah.
think a conversation of second or third or fourth or fifth dimensions is even like the kind
A
of thing.
thoughtful conversation.
Yeah, it's like, oh, what? Yeah, they exist. What does that mean? Who the fuck knows?
We just know based off the math that works for everything else we see. The math also says there's something there that we cannot fucking comprehend.
Yeah.
And then
There's
the
a lot
next,
that the meat we are made of can't really perceive.
Yeah, exactly. The next comment I made, which is totally just me being, well, actually, he just said Mars and Venus may also have had oceans previously, and I just on that may of my personal opinion as a Mars scientist, it's more like it most likely, like almost definitely had an ocean in the past. Just saying, like some people are like, no, it was icy, but there's like some pretty compelling evidence that it's not, and those people are kind of silly, but whatever, it's fine. Anyways, that's all about that one.
All right.
Next.
Next.
A's 2 cents. Next.
This is let's see what else. I'm just double checking that we're going in order. This is one I actually also posted in the Discord and put like a link to.
Oh, the
that
bathysphere.
No, but that's also great. It says everything runs on DNA, RNA, and ATP and proteins. And I had never heard of ATP before, and I briefly read up on ATP.
Okay. How had you never heard of ATP before? Is that not in bio?
But the last time I took bio was in 2015.
All right, fair enough, I guess.
And she didn't even make me take the final.
Oh, well, this explains.
Oh.
Hey. But if anyone feels like a presiding, I feel like I'm not the only one who might not know what ATP is, please. I know I'm stupid. Please.
No, I'm like I guess it just surprised me that you said it was the first time you'd ever heard of it, and like
It's probably not.
It could also be something that they barely touch on in bio, because I took multiple bio classes over the course. Also, like my first bio class was New England biology, so like that's different.
Like, yeah, I will say Utah high school science classes aren't exactly, like, especially when you're in Mormonville and they're trying to teach you about evolution in biology class. There's a lot that they kind of just are like, no, it's okay, it's okay.
It's okay, don't worry about it.
Yeah, my
Yeah.
biology teacher was pretty good. I do just like I always liked memorizing things, and so I memorized the one photosynthesis formula.
Mhm.
I can't recite it now, but I memorized it when I was in biology, so that's why I sort of can instantly tell you what like ATP is.
Mm-hmm.
So, do one of you guys want to give the spark notes on what ATP is and what it does?
So a lot of processes of living beings produce ATP. You know, like what is it? Plants take water and sugar plus the energy of the sun to make ATP, along with a few other waste products such as CO2.
Mm-hmm.
And basically, those plants take that ATP and convert that to energy, and as a waste product, create ADP, which, chemically speaking, takes away one phosphate.
Okay, so I am now recognizing this process you described, but we never put a name to it. It was just like energy.
Okay.
This energy. So that would explain why I probably didn't know what ATP was. It doesn't seem like they ever defined ATP in my memory. It was more just like, it's doing this, and then this is energy, and this energy is getting transferred to a different energy, and we've literally just called it energy the entire time. So
Yeah. ATP is basically the currency that your body runs on. It is the format that energy is transferred in. You have your cell, like mitochondria is the powerhouse of the cell. Is basically producing these ATP packets that can then be sent anywhere in the cell and basically power any function of anything in the cell.
cool.
Am I off
Yeah.
base thinking that this is like the product of aerobic respiration?
It is also the product of anaerobic respiration and aerobic
Yeah.
respiration. Ugh,
Any of the respirations.
Okay.
Huh. Cool.
Yeah.
I like
There are many processes that result in it because it is the thing that powers every cell in your body.
how did Fraser word it? I briefly put it in the chat too, and Fraser said something that I really liked. Oh, it is the coal of the mitochondria.
Exactly. Yeah.
And as we all know, the mitochondria is the powerhouse of the cell.
Mm-hmm.
So, cool. The next is just a quote that I put down that I really enjoyed, which was just Galileo was no idiot. I don't know why I enjoyed that a lot, but I really enjoyed that.
It's a funny way of phrasing it.
Yeah, he was no idiot, and he knew where the money was coming from, if I remember correctly. That's what that was about. He was
Yeah.
he
Oh,
named
right,
the
that's
moons
the
of
context.
Jupiter the stars of Medea. And it's
He
like
started
The Medici.
Medici, that's what it was.
to honor
In
the Medici
retrospect, that
family.
seems super wholesome. Like he was like, "Look, these people really helped me out with my research," and then you kind of translate that into modern times, and it feels more
It's
like
just
lobbying.
bureaucracy.
Yeah, and you
Mhm.
get sort of uncomfortable.
Science always mixed with the bureaucracy, and hence why there's an entire movie called Tomorrowland, where there is no bureaucracy, all the science gets to get done.
Mm.
Yes.
Y'all? The next comment, we're still on page 15. Woo! It says, but when it comes to biology, we have yet to make that leap, because he was talking about geology beyond Earth, physics beyond Earth, chemistry beyond Earth.
Mhm.
And then he says, but when it comes to biology, we have yet to make that leap. Does biology work beyond Earth? Does the phenomenon we know and love called life work beyond Earth?
I think statistically, it's got to be very unlikely that it doesn't.
So my question there was, hopefully it does. It'd be pretty strange if it doesn't. But if it does, when do you guys think will make that leap? Like, what do you think needs to happen for us to make the leap to discovering does biology work beyond Earth?
So
Well,
I
so
think.
I would say that
Go ahead,
uh,
Stealth.
I think like the origin of life could be in question, but if let's say the like chemical composition of the atmosphere and there's liquid water on the surface, if you brought life from another planet and dropped it there, obviously the biology would still work.
Right.
And I think much more of what the question is, does biology work beyond Earth, is much more a question of
The origin.
well the origin, and is what we currently understand as biology, is this the whole thing? Is this DNA, RNA, ATP formula, cells? Is this how biology works everywhere?
Yeah,
Or
it's
are
kind
what
of
we
like
doing, or is this just how terrestrial biology works? Is this
Yeah,
some subset of what biology actually is?
right.
Like, you could envision that, like, if we were to make it a billion light years away and the elements were different, we would have such a small understanding of what chemistry actually is. We could have a similar discovery in biology where we discover, oh, our entire concept of biology isn't actually the whole thing.
yeah, and like
Similarly to how if there was a different set of elements somewhere else, we'd come across the fact that we barely understood any of chemistry.
yeah, and I think the best way I could relate this to like what I know is back when we only knew Newtonian physics
Mhm.
rather than relativistic physics. It it worked, but it didn't really work beyond Earth. Like, and we didn't know that for sure. And if we had stuck with that, maybe we never would have found out because let's be real, like our rockets wouldn't have been good enough if we didn't know about general and special relativity. But still, through the physics that we were able to observe from Earth, we were able to in a way derive to general and special relativity, which, as far as we know, in some of the farthest reaches of space we can observe, has been true. It's a physics that we learned here as humans in a terrestrial way that we are able to apply to supermassive black holes in other galaxies that are the center of other galaxies. And like the fact that I think what he means works beyond Earth, like, is biology going to be as stable as that? And if it does, when will we be satisfied with our answer? Like, say we find life
Oh,
on
that's not
Enceladus
gonna
or
happen.
Europa, like, how satisfied are we going to be that even if the life may be a bit different there, that we have the complete picture? Because I don't think we will be, and it would take eons for us to be truly satisfied with that.
No,
But
I honestly I don't think that we will ever be satisfied.
Yeah, that was sort of my read on that as well, where it's like, let's say we find, evidence of life on Mars that was ATP, RNA, DNA based, and we find something on Europa that is, also carbon based, but not the same. We're still going to have the question about non-carbon based life. Like, that is still going to be out there. Like, not
right,
finding it on Titan doesn't mean it's not anywhere. So I feel like it's the kind of thing that you'd almost need to do an exhaustive search of the observable universe before you could be confident that you had the full picture of, which is interesting because that's very different than chemistry or geology or physics, that
yeah,
you can test these things without having to have
Well, Mr.
microscopic
Hand,
level view of
like he
every
didn't
planet.
really approach the subject, but he brushed against it when he was talking about just the fact that shit, I lost it.
No worries.
I
Carry
sort of
on.
wonder if like carbon-based life and say nitrogen-based life could or would exist on the same planet.
Yeah, like that's the
oh,
sort
that's
of thing
interesting.
where it's like you could have all sorts of crazy interactions, that just because biology is such an open-ended discussion of like what does that really mean? Like, biology is life. Life has sort of a loose definition, and
Yeah,
unlike chemistry, that's like, oh yeah, it's the interaction between the elements.
Yeah, which the elements are this amount of electrons and this amount of protons.
Right,
It's not
they're
like
quantifiable in a way that biology is almost qualitative to decide what fits in the category of biology.
It's also really interesting to think about like the concept of maybe life existing in the clouds of Venus or the clouds of Jupiter,
Mhm.
like big gas giants. Like, because too, even as we expand our thinking into perhaps nitrogen or non-carbon based life, so few people think about, well, there's still a lot of really useful things in the atmosphere of Jupiter or say Saturn.
Mhm.
Is there another process then that we know of other than chemosynthesis that could power some sort of life?
Mhm.
Um, which also kind of leads into the next point on page 16, which is the quote, "Do we live in a biological universe?" And I don't have any more comments on that other than, to you guys, do we live in a biological universe?
I would almost consider that like a binary question, which I would answer to yes because we exist.
Exactly, completely, 100% agree.
Yeah, and like I like to think, especially there's something at the end of chapter 2 that I commented, but um I find it almost impossible that we don't on some level live in a biological universe.
Yeah.
That
I
we're
mean,
that special.
Yeah.
So the question you're asking is almost like, is there biology beyond us? And by that standard, do we live in a biological universe?
Mhm.
Yeah, like if someone was out there like kind of in Men in Black with the galaxy marbles playing with universe marbles, would they pick up our universe marble and classify it as, oh yes, this is a biological one. This is one teeming with biological activity. And what does that count as? Like, when is it defined as biological? It's kind of the question too of like how many grains of sand make a mound? Like,
I
is it
think
one? Is
the other
it two? Is it three?
and something else that I think is super interesting is if you're discussing, is this a biological universe? Meaning, if your question is, how many times did life arise within that universe? That's one thing. On the other hand,
Yeah.
at some point there's a track here where a species takes over an entire universe. Like it is, oh yes, this is a universe teeming with exclusively human life because they went and eradicated everything else, for example. Is that a biological universe if it's, full of if life only was created once, but that life was so dominant in its universe that it makes up the majority of the universe now?
Yeah,
I would
almost
say
the
I would say
difference
yes.
between biological universe and a biologically diverse universe.
Yeah, exactly. Like,
Exactly.
I would say even if all life were somehow like destroyed and
Mhm.
that there was like, no life except for the dominant species as you put it,
Mhm.
I would
Mhm.
still consider that a biological universe because there's the potential for life.
Okay, and now what if it wasn't that one species eradicated all the others? What if, in an entire universe, life only happened once, but that like is that a biological universe? And does
Yeah.
the size of that biology or like the influence of that biology affect whether or not you consider it a biological universe?
You're saying that like the capability for it to support life is taken away
So
somehow?
no, it's what I'm saying is the difference between life arising once in a universe and life arising 100,000 times could be
Like
your
you
determining factor.
I would say once is enough.
Okay, once is enough, and it doesn't matter how. Okay, well, if once is enough, then yeah, that makes sense. I
Yeah.
Because
understand.
And
then if it
that's
if
the
it
stance
happens
I would
once
take.
and then they die out, then you can't say, "Oh, well, there's not going to be more life,"
Mhm.
because, maybe there is.
But, like,
That's
what if you were looking at the entire time scale, like the start to the end of the universe, and life only pops up once? And it's not that other planets don't seemingly have the capability, they just don't, which would almost indicate that on some level they are inhospitable. It is not possible, or like that one piece of life is beyond special. It's a
mhm.
freak accident, a once in a lifetime thing. Like it shouldn't have happened. Would you still call that a biological
Once in a
universe?
lifetime.
Yeah, I would
Once
still
once in
argue
a
that that's
universe
a
time.
I would still argue that that's a biological universe because there's the possibility of life. Like even
Mm.
if it's say a freak accident, like I wouldn't call it an accident as much as, well, it couldn't have happened if there wasn't anything there.
But
hospitability.
it knew how it ended though, so there is no more possibility. Like the book's opened and closed. It only happened once.
Yeah.
It's being filed in the universes that did exist folder somewhere in some dimensional
Yeah.
being's office. Like,
If there was life, then it was a biological universe.
And if there was never life, but there was perhaps all of the ingredients for life, it isn't.
I would argue that that is also a biological universe.
Huh.
Interesting.
Just because there is the support, like you could say, like realistically, that there could be life out of that universe.
Because like, even though it never happened, there was a chance.
Yeah, with similar logic to life being wiped out, but there's still the building blocks there. That I call that biological universe. If there are the building blocks there, regardless of if there was life, then I call
Is
that a
there-
biological universe.
Is there a
Interesting.
delineation between
Although I
organic
might
and
retract
biological
that
here?
now that I think about that.
Mm-hmm.
Interesting.
It's all very new for me to think about.
It's a lot to think about. I
It's
think
it's
the
a
term
profound
a biological
question.
universe is very, very open-ended.
And I think that's part of the exciting part about the question. It's an interesting way to dive into, like almost that question, how many grains of sand make a pile, but in a far more complex understanding here. Like
Uh,
when does something become biological?
Yeah, because I also think about like imagine a universe that's entirely sterile, and at one point there was a singular,
Microbe.
not even a microbe. There was a strain of DNA that existed and attempted to self-replicate and failed. Was that a biological universe?
Yes.
It's
No,
like
I would disagree, but
I
Yeah,
would say the perspective also matters. Like, are we talking about this from the perspective of like the universe itself, or are we talking about this from the perspective of us who know about biology, who know about DNA, etc.?
I mean, I would imagine the only people who can class something as biological or not would be people who know about the existence of biology. So you'd have to be an external observer looking into another universe somehow. So in
Well,
other words, we're
so-
omnipotent in magic at this point.
Yeah, so
Yeah,
now we're
so-
talking
We are
about
gone
the,
on
like, the
another
difference between the
universe.
discovery of mathematics and the invention of mathematics.
Hmm.
Yeah.
Yeah, I suppose. So by that sort of classification, that we're talking about it, us humans classifying the universe as biological, that if it has the building blocks, then life is possible, therefore it is biological.
Interesting. Yeah, that makes
Hmm.
sense. Versus like, yeah, I guess I could see that argument. I think the term biological universe is just too open-ended to really even discuss. It's like,
Yeah.
what does that actually mean in any sense other than like, oh yeah, there was something alive or there wasn't something alive. And even
Yeah,
then,
you
I'm not confident in calling something a biological universe if it had life for 30 seconds at one point in its 40 billion year lifespan. Like that seems
Yeah, because how long has life exist? Like, have you guys ever heard of the universe's calendar, or
Yeah, or
what
like
do
a
they call
clock.
it? Yeah, like how long is our existence? It's like 8 minutes or something.
It's like
Yeah.
8
Less
minutes,
than that.
yeah, or a minute,
So I
whichever.
would say we're officially biological. So for
is. Hello,
Thank
Craig
you, Craig.
again. All right, the
back.
recording cut out there for a minute for unknown reasons.
Yeah, so like maybe not conscious is the word I was looking for, but
Like-
more on the lines of it has some sort of survival instinct that you can identify, and it's around for more than 8 minutes. And there's at least 2 instances of this. I'd be a little tempted to call it a biological universe.
I think the key there is like successfully self-replicating.
Yeah.
And,
Like,
like-
it would have to self-replicate if it existed for more than 8 minutes on the universal time clock.
Yeah, but
Yeah.
the universal clock, like that's really hard to judge because we haven't been alive for 8 minutes on the universal clock. If you're looking at looking at it from the end of our universe,
Oh, that's fair.
it's only up till now.
Yeah.
So like, how long is that realistically? Does it have to be 1%? Because I think there's a totally reasonable shot here that our universe, if we're the only life, does not end up being biological for 1% of its existence.
Are you
Ooh.
so? Are you guys familiar with what a tardigrade is?
I am,
The
yeah.
living
Yeah.
water bear.
A target rate? What?
Tardigrade.
Sorry, could someone type that?
Yeah, I got you.
A
Because
tardigrade.
as far
Sea
as
bear.
we know, they are
I think.
static
Tardi-
and alive on the moon.
Tardigrade.
I don't think they are all. Oh, sorry, it's an I.
Yeah,
Here,
I have no idea what that is.
they survive in like next to magma, and one has survived several minutes in the vacuum of space.
Mm-hmm.
Oh, I've seen one of these before.
With
They're
your
kind
eyes?
of cute in a weird way.
No.
But there
Well,
was an
yes,
there
with
was an
my
Indian
eyes, not
spacecraft that
real
impacted
life.
the moon with a bunch of tardigrade.
Mm-hmm.
So if at least one of them survived on the moon, then the moon is populated.
That's true.
Maybe. This is a great segue into the next point. Sorry, because we've been on this a long time, but might as well make the next point while we're talking about it. The next quote says, "This possibility, however remote, would make it difficult to be completely confident that any life we discovered on Mars arose separately and independently. In other words, that it was really Martian.
Mm.
Life on Mars could be from Earth, and my favorite part, and vice versa." Like the thought that we are not actually like a tertiary, that's not the word, that's a color. Terrestrial being when we're not. Maybe we're all Martians, technically.
We're adopted.
Some meteor came over from Mars when Mars used to have like an atmosphere and oceans and used to be the better temperature than Earth because at the time Earth was too hot. And at just the right moment, at the right time, a meteor came over and was like, boom, life on Earth. And we're all just Martians. Like, just let that settle in. We could be Martians, and I really like that idea. Like, I want to be a Martian.
It would have
Just
had
move
to
to
like it
Mars.
would have had to have been an object that hit Mars hard enough to spray that
Yes,
material out, and then that material hit
correct.
Right.
early.
Yeah.
But we know that also happened to Earth while life existed.
Yeah, there's a
Yeah.
lot of water that hit Earth.
Massive impact while dinosaurs existed. They got wiped out, but life continued on Earth.
Well, I mean, even before dinosaurs, something hit Earth hard enough to build us a whole moon, didn't it?
Yeah,
Right.
Things have been hitting each other in the solar system for a long time and spraying all sorts of bits of everywhere else.
It's like just solar system sneezes.
Mm-hmm. I mean, I think in the
I love it.
in the chapter he even mentioned like the specific number of impacts that one would have expected over the lifespan of Earth.
I highlighted this. It says, even if just a few microbes per rock survive, there's enough impacts and enough injected that the total number of Earth microbes delivered to Mars has been calculated to be in the range of tens of billions of cells over the history of the solar system.
Yeah, it's like that's a disgusting figure. And I would imagine, it's probably a similar figure in reverse were there to have ever been life on Mars.
Right. And we know that Mars would have been, in the early times of the solar system when the sun was hotter, arguably more habitable than Earth. If it was, because we talk about different like time periods on Mars the same way that we talk about different time periods on Earth, which there's a time that we classify as like the wet, heavy with atmosphere period, if that's what you want to call it. Like, it's hard to say whether or not it was actually warm, but we do know it seemed wet. Some people think it was cold and dry, but a lot of people agree that it was a warm and wet existence then, and that was well before Earth was really habitable at all.
All right.
Which is just like an interesting thought.
I mean, it makes sense. We're all Martians. Confirmed. Base just confirmed it.
Yeah, something about the thing you said a second earlier was, about the rocks going between Earth and Mars. About like Europa, this university, British Columbia, sent 6 million theoretical rocks out of Earth, and like half a dozen went to Europa.
Yeah, that's so like the the chance of any life from Europa or Earth being exchanged is just so heinously low that like
Yeah. The
Yeah,
cross
and as
cannon.
well, it's hard to get through the ice shell of Europa, and also there's a ton of radiation just raining down on Europa every day.
Well, the thing though about Europa is that radiation doesn't really get through the ice.
Right, but
Right?
if you were
Yeah,
to
that's
have
that's
something that
why.
landed on the top of the ice shell, it would still need to make it into the ocean before it got irradiated, which I think was just adding to the lack of likelihood of biological exchange between Earth and Europa.
But
Yeah,
then
you'd have to have
imagine
basically the equivalent of like a depleted uranium shell
not to
to
Yeah,
punch through the ice and bring life to those oceans.
yeah,
not to go back to Mars, but this I feel like say we did go to Europa and we found DNA and RNA in that ocean, it would almost be the same question of the methane on Mars.
Mhm.
Like, was this contamination? Was this once in a lifetime example of somehow some rock from somewhere did actually take life over to Europa that started with RNA or DNA? Or is this evolutionarily like eyeballs?
yeah.
Where
Eyeballs?
Yeah, like eyeballs evolved 8 different times, like
Convergent
Oh, right.
evolution.
independently
Like
from each
crabs.
other. Yeah.
Yeah,
Which just shows like on Earth at least, a preference for something that can see and perceive the visual part of the light spectrum.
Yeah, I feel like
So,
they
like,
do
is
go
there something
pretty
about
in
living in
depth.
our universe that prefers RNA and DNA?
Yeah, I
There's
feel
a
like they go
lot of
pretty in depth.
variation in the way perceptors of light have evolved on the planet, though.
for sure. And I think that's sort of the idea is that like if we were to find RNA DNA on Europa, the question would be, is this panspermia, that idea that it traveled, or is it just convergent evolution, just like how there were many different ways to develop an eyeball, there could potentially be many different ways that lead to RNA DNA, just because it is such a useful mechanism for iterative life.
Well, yeah, and I get what you're saying, but like, imagine let's hypothetically imagine that some other life form develops on some other planet in a different solar system. It's still got an orbit, like a planet orbiting a sun. It's still going to need to somehow navigate the topography of that planet.
For
It's
sure, for
probably
sure.
going to use some evolutionary process to like use light to do that,
Yeah,
because
absolutely.
light
And
is still hitting that planet.
I think that's that's an interesting point too, because even if for example, RNA DNA isn't the system they're using, they would probably still have something akin to an eyeball.
Right.
Hmm.
Yeah.
That's what I was.
Yeah. No,
You said it
I
better than me.
I just rephrased it. Do not worry.
All
Uh,
right. We good there?
yeah,
Yeah.
I think we've established that life on Europa would be kind of neat.
It would be pretty neat. We've already kind of discussed this, but I thought I'd point it out again. The quote, "When I refer to alternative biochemistries, I'm still referring to water and carbon-based life. What is alternative here? The prospect of finding different molecules that run the show that is an alternative to DNA." So that's kind of what we're talking about, like something that is similar, like akin to an eye, but it's different. But the question I had here is, say we somehow on like maybe Titan, for example, discover like non-carbon or non-water based life, or like if it was on Titan, it would likely be carbon based non-water life. It would most likely be methane based life. Like, would we be smart enough to classify that what we found is life? And like
Would we
how
be
would
able
we
to
classify
detect
that?
it?
So, do
Yeah,
you guys remember your, I don't know what, actually, I was going to call it freshman year biology classes, but I don't know what year y'all took biology. There are like 7 characteristics that define life.
I don't remember that at all,
Let me
actually.
Oh,
see if I can find
I do.
it's like talking about if fire is alive.
Yeah, so like, there's
It's like
there
Chungus
we
or
go, 7
something.
characteristics of life. Responsiveness to the environment, growth and change, ability to reproduce, have a metabolism and breathe, maintain homeostasis, and then being made of cells, passing traits on to offsprings. So those are currently the qualifications to be considered life on Earth.
Okay. So I feel like
Isn't response to noxious stimuli one of them?
Yeah, responsiveness to the
I think
environment.
that's the first one he said.
Oh, yeah.
Yeah,
Uh,
you got it. Yeah, absolutely.
but like in response to that, I do believe that if there was like methane-based life there, if there were humans there, we would eventually be able to identify it. But I'm talking like in the limited scope of what we are actually able to collect from a spacecraft. You know, do you think we're like have the ability to identify something as life when it takes 8 years to get something there?
I think we would, purely based on scale. So
Mm.
there's an issue here where a cell, maybe there wouldn't be cells, but to have a complicated enough piece of chemical mechanism, like a complicated enough molecule to do any of these things, it needs to be a certain size. And at that size,
Mm.
it is very obvious whether or not the whole thing is like homogeneous. It's just like a big piece of, you know, a rock, or if it's, you know, doing something. I think it would be a question of scale. And if you found something that complicated in the appropriate scale, you could pretty easily assume that it didn't just happen to coalesce. It isn't some Matryoshka cell. It is something that was, you know, maybe not intentionally designed, but it was intentionally replicated.
Interesting.
I think that is going to be your dead giveaway, is going to be how large it has to be. And when you find something in the right size range, it would be very obvious that it is not just you know, what I would call a naturally occurring piece of, you know, detritus
Right.
floating in the water.
To like throw back at you though, what if it's something like a tardigrade? And we have the instruments we have, which aren't super, you know, like we don't have cameras to see tardigrade. We have things measuring chemistry levels, we have things measuring heat, you know, we have things measuring radiation, we have things measuring like the content of certain chemistries, like
You say that, but we do have cameras that can take pictures of tardigrades.
but not going to somewhere like Titan.
We don't currently, but like,
And I'm saying currently.
would is there no photographic, like, I guess I would have to look at what is the armament that they're putting on this said mission to.
If it's anything like Martian instruments.
Well, I imagine it wouldn't be. Looking for different things.
Well, no, I'm saying like not like Martian instruments, the resolution of Martian instruments. Let's put it that way. If it's anything like the resolution of Martian instruments, which are a lot easier to put there because one, it's a shorter journey, two, we have an easier time communicating with it, and three, we've sent several different things. So we kind of had like a trial period about like what actually works there and sending something that works better. I would not have confidence in the ability for like current Martian instruments, if they found tardigrades, to even know that they found tardigrades.
Yeah, I would say that it is with an orbiter, it is going to be very unlikely that you're going to be able to tell whether or not there is life in the ocean, like, you know, 3 kilometers down.
Yeah, I'm not talking about an orbiter though. I'm talking like Martian rovers. I do not think they have the ability to detect something that even is carbon water-based life, like a tardigrade, and then let alone like, well, I could see it for a tardigrade, but imagine something the size of a tardigrade that is non-water based, like, because we don't really know what that looks like, and that's why I guess what I was getting at, you know, are we smart enough? And I think you're right, on a certain scale, we're definitely smart enough, but I would argue that once it gets small enough, there's no like we might be able to muse and say, "Oh, this could be life," but it wouldn't be like we have found life.
I mean, what I would, my only counter to that would be, if you have an orbiter, or you have a rover on the surface of say Europa, and you have picked up a sample that does indeed include even single cellular life, we have instruments that would be able to tell. And I think, like, you know, you can see a single cell with a a reasonably cheap microscope, and I can't imagine they're going to be sending a cheap microscope.
I don't think they're sending a microscope at all, but like similar things, yeah.
Right, but like at that scale, we have the ability to see individual cells, and I think that's the type of scale we'd be able to confidently say something at, because at that point,
Right.
it is large enough that it is going to meet those qualifying factors for life, and on top of that, it is also verifiable, right? You can see the various, even if it doesn't have like organelles in the classic sense of a terrestrial cell, it's going to have something going on that is going to involve like a complicated organic chemistry mechanism.
Yeah, like if we were to detect it, it would be it wouldn't be seeing a cell or seeing a cell reproduce. It would be some sort of chemical process. Like we detect complicated chemicals that don't usually exist
Like
sans
methane.
life. Yeah. Well, out there it wouldn't be methane, but something similar. Like something that you're looking at and you go, in this environment, there's no way that this just exists this way. But then like we know that about biological life. So then my question there, like you're saying that it's like, okay, so we see chemical traces of something strange going on. Is it some complicated geochemical process that we're looking at? Is it actually like, because we don't know what non-carbon, non-water-based life looks like. Like, does it even have chemical processes that happen like that? Like, are we going to recognize it? Is it super simple? Like, who knows?
I mean, I think the answer here is pretty convincingly like it depends on like to have a metabolism, right?
Yeah.
Like that means it is turning a a naturally found commodity into something that one would assume is less commonly naturally found.
Yeah.
So like you might be able to sense that sort of chemical signature, but I would also say like I guess it depends less on can we find the chemical signature and more can we rule out the other explanations for it.
Right. And I think this too just comes from a bit of a disconnect of what people think the data we get from satellites and rovers looks like versus what we actually get. And just coming from a place too where we get a lot of very detailed data because it's close and we have the ability to do that. The data that we get is very, how do I put it? Like it's not simple, but it's certainly not as complicated as people think it is. Like a lot of the process happens after we receive the data. It's turns into a lot of physics that is oftentimes messed up, uninterpreted, or the fact that like I'm an undergrad student and I can still look at data that's been looked at for 30 years and still come up with something different. Because like the actual data we receive is so what's the word I'm looking here for?
It's coarse.
It's coarse, yeah. It's non-refined. It's very wow, that's kind of funny. Yeah, it's very broad. It's no, the word is like
not
the
specific.
yeah, it's the word is kind of like how you talk about sciences. Like you have mathematics, which is the very base, and then very complicated, like where we're at, which is biology.
Mm-hmm.
And in terms of like that scale, we're at like the mathematics physics level of like what we're talking about, like the data we get here.
And I think a lot of that is because the types of things people are looking for on Mars are very, very, coarse assessments. Like you're not realistically looking for like something that is alive on
That's
Mars. Like
fair.
that is not the expectation. What you're looking for on Mars is chemical processes. That's why the data you're collecting is good at finding chemical processes.
Yeah, whereas I guess Dragonfly, like one of its main missions is extraterrestrial habitability and prebiotic chemistry, which will have a different set of instruments.
Even mentioned in the book, the fossils are not super great at giving you the actual picture.
Right, exactly. I think what would it like, if you're gonna be able to have water samples from the seas underneath the ice, which I don't
Mhm.
think is a realistic expectation, but like, let's say you were, I think you would be remiss not to have the ability to run an analysis on any large particulate you pull out of that water. Like,
Yeah, that's fair.
and even let's say if you can't explain why, or like even if you can't take a picture of what that particulate looks like with a microscope, you can still do like a centrifugal density analysis and figure out, okay, so what was in that water? That's interesting. It has this very, very complicated, nuanced balance that is very consistent. It's like, oh, there is constantly 8% silicon and 4% nitrogen, and like, it would be specific enough that I think you could probably reverse engineer that there is no natural or like commonly found
Physical way.
chemical that, or sorry, yeah, physical, that's the word I'm looking for. There's no physical system known to man that is going to create that specific balance of chemical soup, outside of there being life that is coalescing into certain densities of those elements.
Right. I guess too, part of my point too with that question was I also wouldn't be totally surprised, say like an eon from now, like we find something, right, and we're like, nah, it's nothing, and then like our future ancestors are just like, ah, those fucking dumbasses, it was clearly a silicone-based life. Like, I
mean,
wouldn't
that's
be
fair.
surprised.
I think it is hard to say.
Yeah, that's
I think it
certainly
would
the case.
depend a lot on what instruments you had, and a lot on probably what that life looks like.
Yeah.
Like, if it is even if it is silicon-based life, I'm sure there's a chance that silicon-based life is so similar that it's literally just all the carbon atoms are replaced with silicon. Like, that's a possibility.
Yeah.
The two are chemically very, very similar.
Just to touch on what Ace was saying, like the scientific method is the best tool we have available to us
That is
to
true.
like figure out what we're looking at here, and like even extra solar.
Yep.
And
Yeah.
ultimately, if that changes, we'll have to adjust everything, but it's what we get.
Yeah, it's certainly, these are the instruments we have at the moment, and like, we just have to do the best with whatever we get whatever we have when we get there. But
Right.
I think it'd be interesting to see what they kit the Dragonfly out with.
I would also like these are the times I wish I could go forward in time. Like when people are like, "Would you go into the future?" I'm like, for this reason, yes. Like I want to know how fucking dumb we are now, if that makes sense. Like,
I want to
I
know
want to know.
how far into the future do you have to go before we've found extraterrestrial life? How long does that take?
I want to know how far into the future we have to go if life continues this long for what the science and physics we're doing now to look like how we look back on cavemen creating the wheel, like, oh, wheel rolls. Like, I think that would be really interesting.
The internet ultimately probably is one of those. It's one of those landmarks.
Mm-hmm.
Yeah, I was thinking about that. I'm like, I look at my laptop and I look at my PC and TVs and I'm like, wow, it's so cool. And I'm like, oh man, like God knows what they're gonna think of us like 100 years from now when they're like, yeah, to like search the internet, they had to like use a keyboard and manually type it in. Like,
Yeah, they couldn't
it's gonna be
just
some
think of
stupid
the thing.
bullshit. Yeah. And even then, not all of it was accurate. People would put out like fake stuff and people would have to do like even more research and it took time and it's gonna be like, God damn it. Like I thought we were so
imagine
smart.
when people weren't like thrown in jail for putting up fake stuff.
Yeah, or it'd be like, imagine the internet just wasn't like they didn't even have the singularity that could just like answer anything for them. They just like took fucking guesses, and it took them years to come up with answers for some things. Like sometimes scientists took like 6 years to answer a problem, and it'll be like, oh Jesus, like I know that's
Imagine
where it's going.
their computers only did trillions of computations per second. That's such a small number.
It's
What a
such a
bunch
small
of
number.
schlubs.
Their computers only worked with zeros and ones. How basic. Oh god. Like I hope that I get to at some level see that happen. At the same time I hope I don't, because it's just gonna make me so fucking miserable. To be like, oh, the time wasted.
I'm old enough that I'm actually like watching technology pass me by.
Mhm.
That's really, really entertaining and also terrifying.
Yeah,
Yeah.
I already think about too. Like I have explicit memories of, I don't know, was it my freshman year of high school? Like not that long ago. I mean, like how cool, like when the first iPad came out, that's probably when I first had those thoughts. And they would have those little like fat stylus things. And you couldn't really write or draw with them, but it was so cool because it was like a pen on technology. And now I literally have a pen connected to the side of my like tablet laptop here, where like the screen can disconnect and flip around, and like the harder I press, like it will go on darker. Like bullshit. What?
Yeah, very cool stuff.
Yeah.
You sweet, sweet summer child.
Yeah.
I know what I sound like. And
I
that's why
was
it pains
talking on a
me.
landline with one of my friends the first time we both hooked up our 28K modems.
Hell yeah.
Nice.
Yeah, and I still remember when I had this stinky little computer in the corner of my room, and I like just drew little things in MS Paint and played, I don't know, checkers or whatever, and
Do you
that
ever
was
just
it.
like scribble and then use the paint bucket option to like make basically a kaleidoscope stained glass window?
Yeah, like a little kind of like blob kind of thing.
Yeah, yeah.
Yeah, no, the paint bucket option always colors your whole thing because you didn't totally close the section.
Oh my god.
Yeah, that you're like, damn it.
Uh-huh.
Alright, sorry. As much as I'd love to continue this,
Yeah.
I know
Oh,
I'm
right,
a summer
yeah.
child, and that's the
So
exciting part. Okay.
Yeah, we are over halfway of our sort of expected time.
Woo.
Let's go.
Well, thankfully we're at essentially page 20, so
Yeah,
Hell
we're doing alright.
we're pretty
Except
much
for
on
the fact
pace.
that Tri said all his comments were in chapter 2,
Oh
and
no,
so
it's okay. I think they won't be particularly long. It looks like at least some of them are relatively similar to things other people said.
yeah. Alright, the next comment I just made was kind of a revel at technology, which was the expedition's Royal Navy ship, the HMS Challenger, carried its crew around the world's oceans, covering a distance equivalent to a third of the way to the moon. It was, and remains to this day, one of the most important pioneering scientific expeditions to set sail. And during this, they also dropped their line to the total depth it could go to, 8.2 kilometers, and happened to actually find the Mariana Trench, which I just thought was fucking mind-blowing.
Yeah,
Like,
just like
absolutely
by
mind-blowing.
chance.
In 1875. Like, I
Yeah,
love
like
simple science. They put a weight on a measured piece of line and was, like, mapped out the depth of the ocean. Like, genius. Like, I love it.
this
yeah,
I actually already knew, and that's why it's called the Challenger Deeps,
Mhm.
not just the Mariana Trench. It's Challenger Deeps also.
Oh, I assumed that it came from, like, a mission, but I never knew how old it was.
And
Like, I'm so shocked.
what's wild to me is there's no one fucking puts any money into exploring the oceans anymore. Oh yeah, let's go explore space. But like
Hey!
no, like but the fact that our like one of the foremost scientific expeditions to explore the oceans was over 150 years ago, or about
I was gonna
150
say,
years
it's
ago.
like 100 years before my mom was born, like,
Yeah,
more than
that
100 years.
that's insane to me that we haven't like that is still the forefront. Like
Yeah.
that seems like
People are still
nonsense.
sounding like they'll still like people are still measuring the topography of it. It's just it's not scientifically.
Right.
It's
Like if
not
you
a
go
hot
and
topic.
if you guys go and look on Google Maps, you can see all those lines that cross the ocean. That's like, oh, this looks strange. That's just different resolution sounding taken usually by non-science ships that are just it's usually actually transport ships, like cargo ships that take those giant swaths of data you see running across the middle of the ocean. So
That's
frustrating.
so wild.
It's so frustrating.
See, but I also still feel the same about space. Like the fact that, like, one of the things I find most frustrating, which I'm sure is even more frustrating from a marine perspective, is like how much of a budget we have in the United States and the small fucking fraction of it that goes to exploration still. And on top of that, the fact we haven't left Earth orbit, like humans haven't left Earth orbit since 1972, 73. Humans haven't left Earth's orbit. We went to the moon several times and then we're like, nah, we're done. And I'm just like, what the fuck? Like, are you serious?
It's not profitable.
I don't care.
Yeah, I don't either, but
space. Well, thankfully, it looks like it's going to slowly become profitable as we can just like ship the celebrities into space.
Yeah, but on the other hand, like, at least you guys have still been sending things to outer space.
Yeah, exactly.
Like, you know, we haven't even been looking at the bottom of the ocean.
Other than like planet Earth.
Yeah, it's like, you know, unless you're filming a documentary, it's so wildly expensive to get to the bottom of the ocean that scientists can't do it.
Yeah.
And
have you guys watched Planets then?
I have not.
No.
I've just watched all the like Planet Earth and like the ocean. What was the last one?
Ocean.
Our Blue Ocean. That's what it was.
Yeah.
It's like one of those nature shows. I guess I don't know exactly where. It might be on Netflix or Hulu or something like that. But it's the same thing, except they take like 2018, 2019 CGI and build the surface of Venus, and they talk about.
Oh, that's cool.
It's worth watching if you.
Yeah, no, for sure. Like,
I'll definitely look it up.
That like, it's kind of unfortunate to me that like.
I'll dig up a link and drop it in the Discord.
That things like making documentaries like that are the most exposure people have to this sort of thing.
And probably the most money that goes into like actually in-depth exploring it. And that's not even for like the in-depth, that's for visuals.
Yeah.
Really.
Yeah.
All right. Just continuing on pages 20 and 21 were my favorite two pages for the names of things. Notably, we have diving bells, which isn't so weird. The Bathysphere, which I just fucking love that name, and Nonsuch Island. Like, excellent.
Bathyspheres are really cool.
Is it Bathysphere or Bathysphere? I posted that picture of it, and I fucking love it, and I hate it. Like, would not be a person to go down in the Bathysphere or Bathysphere.
No, that was like, but that was when people were like, let's just put iron in there and it'll probably work. And they just hammered an iron thing together and stuck some dude in it, and they were like, see, it works.
Yeah.
Have fun. Hope you don't die.
Ace was like, oh yeah, there's material science involved in building a submarine. Nah, you just like make the walls pretty thick and hope in a prayer.
I guess just I'm talking about going down to like the bottom of the Mariana Trench. Like that's more the level I was thinking.
That's fair. But again,
which does require
you just like make the wall. No, you just make the walls pretty thick and call it a day.
It'll be fine.
Yeah, thick with 2 C's.
I wrote as my annotation next to the Bathysphere, I, in all caps, need pictures of this, and I went and found such pictures, and I encourage everyone else to go find those pictures, because it's spelled exactly how you think it is. Bathysphere. It's fantastic. It's just it's a big iron ball with a dude sticking his face out this very small porthole window.
Uh-huh.
It's fucking fantastic.
Yeah, that'd be super fun. Wouldn't that be fun? You just like, all right, I guess I'm gonna sit here and you're gonna lower me in, and I have no way to communicate back up that I want to come up. So you'll
I have
just
no
leave
way
me
to
down there.
communicate to you that I am fucking dying.
Look, I've had a great time so far, but every time you guys talk about deep water,
Uh-huh.
I don't like it.
I don't like
I
it.
have bad news for you.
Yeah.
Uh-oh.
This is a book on the ocean. No.
Oh no.
Oh no.
No, these are space oceans. I don't have to worry about
space.
space oceans.
That's true. My next favorite quote is quite a long one. It says, "The only other place comparable to these marvelous nether regions must surely be naked space itself, out far beyond atmosphere, between the stars, where sunlight has no grip upon the dust and rubbish of planetary air, where the blackness of space, the shining planets, comets, suns, and stars must really be closely akin to the world of life as it appears to the eyes of an odd human being, in the open ocean 1/2 mile down."
Mhm.
Page 21. That almost like that could be in a Bible, and I'd be like, yeah.
It's pretty poetic for sure. This man thinks he's a writer.
Well, that's just a quote.
Yeah, no.
Like he quoted that.
Oh, he quoted someone else. I see.
Um,
That's just how people talk. though.
Babe's writings. Someone in 1934, and when he went down in the baby sphere, that is his quote.
Mm-hmm.
So, I just wild, crazy, love that.
Wild
That's
and out
cool.
of control.
Yeah, love those kind of like surrealistic descriptions.
Mm-hmm.
I thought it was pretty cool. Just when they talked about discovering hydrothermal vents, like imagine you go to the bottom of the ocean, you're the first person to see a hydrothermal vent. I'd be like, this is it. Hell is here. Welcome.
It's hot here.
I thought it
Why
was
is it
cool
suddenly
that
hot?
I thought it was interesting that the first time they got down there, their submersible bonked the bottom and stirred up too much stuff, and they didn't really see anything.
Oh
Yeah,
god,
there-
that sounds scary.
Yeah, no. Yeah, not a fan.
Like you hit something hard. Imagine not even realizing that it's like the seafloor.
It's the megalodon.
Huh,
Lord
weird.
Fish.
It looks like particulate down here.
Yeah, exactly.
How strange.
The bottom of the ocean seems very dusty.
Dusty. All right. Let's see. Is there any other quotes here for chapter 1? Just a very small one. I liked it's the name of this section, and he mentions it in the last paragraph of this chapter, is calling it our own alien ocean.
Mm-hmm.
Love that.
Yeah.
Because like when I watched Planet Earth 2 and they started showing that shit, I was like, are you sure? Like, you sure that's here? Because no, I don't want to believe that because that's scary.
Yeah, but on the other hand, doesn't matter because we're never gonna go look at it again because oh man, we can make it to space. Let's spend all the money on
Someone
making it to space.
Sounds salty.
You're correct.
We can learn a lot from the pressures that this planet offers us.
Uh-huh.
We could
This is
probably use that. I'm just saying.
This
Mhm.
is one that Rada uniquely pointed out. Oh, I accidentally went past it. It's on page 23. He was continuing from the conversation about alternative biochemistries. He says, following up, base nutrition extracting methods wildly vary depending on context, chemosynthesis, photosynthesis, ... Maybe other alternatives aren't even on Earth. Maybe other alternatives exist on Earth that we don't even know about, is I think what he was trying to say there.
Mm-hmm. Mm-hmm.
So like another kind of how we briefly touched on when I was talking about like, could life exist on Jupiter or Saturn?
Ammonia
Is there
synthesis.
is there something other than chemosynthesis and
Well,
photosynthesis?
I mean, I think part of the issue is chemosynthesis is such a general, like it's a general term for
Yeah.
Right.
using chemicals, and I think chemosynthesis in its the true meaning of that word is totally possible in many environments. It doesn't specifically mean hydrothermal vent.
If we have properly mapped like our elemental table. Yeah.
Yes. Yeah, there should be plenty of other combination. Like, in fact, we know for a fact there are many other combinations of chemical reactions that can produce stored power as well as produce heat and produce both endothermic and exothermic reactions. Like there's such a large repertoire of chemical reactions to choose from. It would be wild to me if this was the only chemical process that life could sustain itself on, or these were the only two.
Right.
Yeah.
I think that's
And I would-
something at this point we all agree on.
And I would imagine even different hydrothermal vents that are based off different geologies probably result in chemosynthesis occurring through different chemical means. I don't know that for a fact, but I'm sure we could look that up. Like if there's a different chemical soup being spewed out of the hydrothermal vent, I would imagine it's going to require a different reaction to turn that soup into usable energy for the organisms.
Yeah. Yeah. I don't know how to comment on that, but yes, I agree.
It seems reasonable.
Seems reasonable. All right, we are now on to chapter 2, the new Goldilocks. My first comment here is what my English teacher would have called an external connection. He was talking about plants grow in the rich soil and help sustain a complex global biosphere. And just this reminded me of something I had recently heard about because of one of my favorite YouTube creators or teams, Yes Theory. They recently visited something in Arizona. I don't know if you guys have ever heard of it, called Biosphere 2. Biosphere 2 was originally a large, what do they call it here? A unique large-scale experimental apparatus housing 7 model ecosystems with active research by teams and multidisciplinary scientists. And originally it was constructed between 1987 and 1991, and it's owned by the University of Arizona. When it was first finished in construction, the plan was actually to have people live in there for a certain amount of time. I don't remember how long that was. But no contact, completely sealed from the outside world, not even like atmosphere exchange from inside that facility to outside. Like the entire idea was completely
I saw that episode
recreating.
of Twilight Zone.
I didn't know that it was an episode of Twilight Zone. But like recreating a complete biosphere. And they even have like the ocean part, and they have a whole desert section. Unfortunately, it had to end short because suddenly they started suffocating. And that's because suddenly carbon dioxide became super rich in the atmosphere, and they couldn't figure out why until a significant amount of time later, which ended up being the concrete that they used to pour the foundations and the floors had to have way more curing time than people originally thought concrete needed. And so as it finished curing while they were inside there, it was trapping oxygen inside of the concrete, which then was no longer being circulated through their ecosystem.
And
the entire thing
is a
got
massive CO2 producer.
Huh?
Concrete is a massive CO2 producer.
Yeah, and the plants just couldn't keep up anymore, and then on top of that, it was taking oxygen.
Yeah.
But if you guys want to watch that, they just made a really cool Yes Theory video on it where they gave them one of a kind exclusive access, obviously because they're influencers talking about it and talking about their research, to take cameras in there and show like where people were living, and it's still working to this day. For the most part, it is now essentially separate from the outside world. Like they don't have to do much conversion or like letting in of the outside atmosphere into the biosphere. I just thought it was super
it's
cool.
working as of today? I thought you said like sort of died off.
I mean, it sounds like they probably had to pull the humans out at some point, and then
It's no longer a human experiment, and they haven't tried that again. And it was super like a big deal when it happened in 1992, 91. But then there was a huge scandal because they tried to just let oxygen in and not tell anyone. And that obviously didn't go very well, which then kind of led to like controversy and people getting mad at them. But the University of Arizona still kept it going for research purposes beyond like human ability to live in there. Like the human ability to live in there was more of just a stunt. Whereas the bigger scientific goal with biosphere is to understand how our own like ecosystem works and how truly complicated it is to replicate. But yeah, it was one of the first steps of even talking about living on different planets. Like that was the whole idea. Like if we could transport this somewhere else, ideally humans would be able to live inside it, no issue. But yeah, super crazy. I highly recommend that you guys look into. I'll link that video too. The Biosphere tour.
Heck yeah.
Yeah, super cool. Super cool. Moving on. Oh, go ahead.
Can I throw
Sorry.
in one real quick?
Yeah.
So I looked into the chemosynthesis a little bit, and it looks like there's one really well understood method of chemosynthesis that is hydrogen sulfide chemosynthesis. But it says that there are also other potential avenues for chemosynthesis that aren't as well understood. I'll just link this.
All right.
Here. So the answer here looks like chemosynthesis is a general term, and there's only one really well understood method through which it occurs. But it says there's also like an ammonia-based chemosynthesis, or yeah. So that's
Yeah,
interesting.
which is why in Elite Dangerous, which I think we all play, you see a lot of
Ammonia-based life.
ammonia worlds with ammonia-based life.
That
Yeah.
would make sense.
That's true. I'm now remembering that from like that classification on Elite Dangerous. Neat.
So yeah, I think the answer here is chemosynthesis is a general term, but yes, there are other mechanisms. There's more than two mechanisms here. So I would in my mind then that would make chemosynthesis as a general term probably more common than photosynthesis on like a intergalactic scale. Like I bet it's
Yeah.
I bet
I
there
do
are
feel like that is kind of what he argues here.
yeah.
That feels like a really hard argument to make, though.
Well, certainly it's arguing beyond the data we currently have because the current data shows a predominantly photosynthesis based life.
But on the basis of like probability of life existing based on counts of places that are habitable, you know, as we get into the Goldilocks zone, there's going to be way more moons around big planets that have tidal heating than
Places
planets that
close
fall
enough to
in
the sun.
that. Yeah.
Yeah.
Which also kind of leads into Rada's comment based off pages 25 and 26, which we've already kind of talked about, is a star-centric, like I'm summing it up here, is a star-centric logic limiting what we think we can find, like our concept. And I think we've kind of talked about that, like, you know, we have to start somewhere. Like, he also goes into like liquid water-based logic and Goldilocks based off what we know.
Mm-hmm.
And I think like the point that I made early on was like, oh, you know, like we have to start somewhere in something that we recognize. Otherwise, you know, it's just like shooting off into space.
So
but
are we imagining like an extra solar system, like a planet that doesn't have a star?
Not even that doesn't have a star, it just doesn't have a significant, like the energy that used by the organisms there are not significantly affected by the sun or their star. It is not photon based life, if that makes sense. It's not photon fueled life.
Yeah,
no,
I think that's
I'm
what he's
following
getting
you
at.
here.
Okay.
I
don't
can't entirely answer your question because I'm just reading Rada's comment, but I'm assuming like we've kind of already discussed it, which is kind of how we're talking about like tidally locked. Like at first we had a star-centric logic, right? And we thought that something had to be in the Goldilocks zone, but then suddenly we learned about like tidal warming from big
like
planets. And so like
tidal
I
warming
think
along with like sort of
what
the
he's
geothermal
getting
events.
I think what he's getting at is like, what is the next logic that we're going to find that might also be suitable for life? And what do we know now? Is it limiting us in the same way that our original star-centric logic limited us in our thought about life existing elsewhere?
Yeah.
And I think we've already kind of answered that, which is, yeah, I think we all agree that there's probably other ways that life can and will exist, but we kind of only have our limited perspective as of now. Does that I that's what I hope he was going for there.
That there are different ways of life forming aside from the star-centric way or the tidal force that generates heat way.
Yeah, and just like we probably won't discover the strangest life in our solar system based off what we're already looking for unless we are the strange life. Just because
Yeah.
we have to look for what we know, otherwise we don't know where to go. Like we have to pick somewhere to go or somewhere to study, and
Yeah,
why
so
not
that we
pick?
can find like another origin of life.
Yeah, exactly. My next comment, which is really stupid, but I really enjoyed it. The next section was called "The Shape of Water," and I jokingly wrote down, "What came first, the book or the movie?" I don't know
I've
if you
never
guys remember that
seen.
weird
Nope.
movie.
Nope.
I never saw it
Great movie.
either. You've seen it?
Yeah, the deaf main character who gets it on with a monster.
Yeah, it gets freaky with some merman.
It's a mermaid,
I was
right?
I don't know. I've just seen the limited, very strange ones, but we're gonna answer this question right
Yeah,
now.
like a fish man.
Oh, this was printed on acid-free paper. So does that
Yeah.
mean like it decomposes or something? I'm confused. So this is copyrighted 2020. So one could argue that the title for this section was inspired by the fish sex.
Gotta be it.
That was my point there. That was all. Thanks for listening. Let's see. What else do we have here? Big brain. The next one I talked about here is water is an amazingly elegant substance. When exposed to cold environment, it naturally forms a protective insulating barrier that, floating atop it, shields the liquid water from further exposure to the cold. And I just said, it's crazy describing it like that because that almost perfectly fills one of those descriptors for life. Like it reacts to its environment. And it's not exactly the same kind of reaction, but it's like oddly lifelike the way that ice and
It
water.
almost seems as if
Yeah.
it's oh man, stutter. It almost seems as if its intention is to protect itself from the cold.
Yeah, and I just
Like it's very easy to personify that.
yeah, I just
Yeah.
thought that was really interesting, especially once again talking about the poetic fact that water hosts life, that it too has personifiable qualities, in
It's
how
very
it
cool like
reacts.
that.
Tis very cool. Haha.
As cool as an ice cube. Huh?
Whoa. Pun.
Pun?
Pun?
Question mark?
Make sure to
Fun.
report this video if you find us too funny.
Yeah, indeed. Remember to like and subscribe.
Like and subscribe. Oh, Jesus.
Make sure to timestamp that.
No, absolutely not. Um, now I'm just kind of looking. We're at the Ferris wheel now. We kind of started the discussion with that.
That's fair.
So
Honestly,
we won't
fuck
go
the
back
Ferris
into that.
wheel.
Fuck the Ferris wheel. I did have one thing regarding like this kind of section, and it's where he goes, the simple fact that ice floats and conducts heat poorly are critical to why ocean worlds can and do exist. And like I logically understood that, but it's when you think about it that way, kind of crazy that one tiny simple process is responsible for preserving so many worlds in what we might consider habitable now.
Yeah, I mean,
Ultimately, one simple tiny process is also responsible for the furnace of every star.
Yeah, that too.
I mean, I think it's just interesting how these small interactions can have such enormous impacts, right? It's
Exactly.
what is realistically happening here? Oh yeah, like some molecules are lining up slightly differently than they would if they didn't have a charge. and because of that, maybe life. Like that is such a wild
But-
butterfly effect.
Maybe an entire world is covered in ice, hiding an entire ocean below it. Like,
Or maybe
crazy.
multiple hundreds of thousands of worlds.
Yeah.
I think if there is one in our solar system, there has to be so many more outside of our solar system.
I
Oh,
very much
definitely.
agree.
I'm trying to read Rada's comment here. Where's my molecules get locked on? Oh, dude, it's really hard to read his comments because he clearly had a train of thought,
Mm-hmm.
and I'm like, what? Because it's not exactly phrased like a question. I'm looking at his second bullet point here. If anyone else is looking at the doc,
Yeah, I'm looking right now.
The search one? Or am I
yeah,
looking at the
yeah.
wrong thing? Okay.
No, the search one, the one that ends in chapter 2, page 31, because we're on chapter 2, page 31. I think he's kind of talking. I'm confused.
I see. I think he's suggesting here that maybe we should be searching for other substances that have similar chemical properties to water, like, where they have these sort of emergent.
All right. And it doesn't talk, even though it says it's talking, kind of.
What's up, GR?
Okay, so anyway,
We're
the
back.
recording bonked,
Rada's
and we had
bullet
to
point
figure
here.
out something. So we're
Yeah.
talking about Rada's bullet point.
Rada's second bullet point. So I think what Rada is saying here was he thinks it would be interesting to search for other materials who have this similar crystal lattice formation, where when things transition to a solid, they expand. And then he says maybe not for finding other forms of life, but for science and materialistic purposes, different chemical reactions than known due to the context. I guess. Yeah, he thinks it would be interesting to look for other molecules that have a similar interaction with the hydrogen bonds that expand when they freeze, and I think like that is definitely something that scientists have looked into, and I think it's a relatively uncommon
It is very
trait.
unique.
Trait, particularly in naturally occurring compounds.
Yeah.
Just because it is so specific to find a crystal lattice that forms so cleanly. Like there's a lot of really lucky geometry that happens to work out with water. Like most things, when you freeze them, they do form some form of crystal lattice based on the intrinsic charges of the molecules.
In
But
fairness, you need distilled or very pure water.
yes, absolutely. Well, I mean, you can't, you don't necessarily need that. There are some things you can add to the water that do not affect it. Like even on the ocean that has all sorts of nonsense in it, ice still floats.
Oh yeah, sorry.
No, that's fine. I mean, it's just a matter of like there are things that do ruin it. They effectively interrupt the polarization of the water that make it so that it doesn't work in the same way. But I think
For example, super ionic ice.
Mhm.
That because it's being condensed in a higher pressure environment, those molecules are forced together more greatly by the pressure than by the orientation of the poles.
Absolutely.
And so that is dense ice.
Yeah.
That's a whole different animal.
For
Yeah.
sure.
And that's why I was talking about ice at the bottom of high pressure moons that were super big. I'm assuming what they're talking about there is a form of superionic ice, like ice that is not created by temperature but super high pressure.
I mean, it's similar, and that was definitely something that I had. Like that is what my comment is down here. This whole blurb about basically the ice at the bottom of the oceans that I thought was really interesting, because it is curious to me that ice is going to form there, even if that the rocky core of the planet would likely be supremely volcanically active just due to the same tidal heating that means there's liquid. Because
Right, but superionic ice exists sans temperature. Like,
So
there's superionic ice that
it
can
is
exist at
not
the
sans
temperatures
temperature, it is
relative to
in spite of
sun,
temperature.
in spite of temperature. That's fair.
Right. And
And I'm
and
just
it is
assuming that's why.
yeah, I would assume so as well. I just thought it was interesting that you're gonna have such an intense pressure gradient that that's gonna overcome, you know, literally volcanic temperatures. Like
Yeah.
that strikes me as very, very extreme.
It in some ways it strikes me as extreme, and in other ways it doesn't. Like, we're talking about things that are far, far deeper than the Mariana Trench. Like, they go way more in, and you have just an overall higher volume of water. And
Mhm.
we already know how intense the pressures get down at the bottom of the Mariana Trench. Like, that is why it is like humans haven't themselves been to the very bottom, as far as
Well,
I'm aware.
relatively,
Because
Yeah.
it just crushes
relatively,
them.
Earth has like a very small amount of water. It's just
And
all on the surface.
yeah. And that's what I'm getting at here, right? Is like we already have such crushing pressures at the bottom of the deepest part of our ocean. Make the planet bigger, give it even more water on top, and make the gravitational pull even stronger.
And
It's
then
like
expose
surprising,
all
but at
that
the
water
same
on the
time,
top to space, and it'll
Mhm.
freeze.
yeah, yeah. And I imagine, like, it's kind of surprising, but at the same time, personally to me, not super surprising that on some planets, ice, even if it's just a thin layer, would totally mess up the chemistry that would have to happen at the bottom of the ocean for life to exist.
I mean, they literally talk about that in the chapters we read,
Mhm.
like
Yeah,
how
yeah,
effective ice is as an insulator.
yeah, exactly. Um, but yeah, I feel like for that case, maybe it's not super surprising, but at the same time, I can see why it also is surprising, if that makes sense. Not really. I know it doesn't.
So I guess the specific part I was talking about here, let's see here. In the next sentence, it talks about under very high pressure, about twice that found at the deepest part of Earth's ocean. Like twice as much pressure, for some reason in my mind, doesn't seem like it should be enough to cause ice that is going to resist like hundreds or thousands of degrees. But I guess that's just like an unintuitive quality of the ice.
But I also feel like you can find out on a very, like, human experiment scale how bad heat is at distributing in water.
Hmm.
Because even if you're swimming in, like, say, a hot lake, like, I went to a reservoir the other day, and there is a noticeable difference if I just put my head more than, like, a couple inches under the water. Like, it goes from, like, warm to, "Oh, shit, I'm really cold again."
Hmm.
And so I wouldn't be
It's a
surprised if it's not that, like, almost the ocean down there is warm, but it's not that warm, and just a couple feet away from it is extremely cold. And
it's
Yeah,
so
a
it's
matter
only
of
being aided
context,
by that. Yeah.
and
that's fair.
ultimately, like we as humans don't really have the context to like measure the differential of temperature in objects in space.
I think that's fair. I think the other thing that just gets me is though, even if that heat from the hydrothermal vent under that ice isn't transferring very far, you're at very least going to have some water immediately around that hydrothermal vent that in my mind could totally support life, even if there is ice. There's like the outer icy shell, an ocean, the lower icy shell, a very like maybe even 2 feet of water, and then the hydrothermal vent. Like that seems like a totally reasonable amount of space to have life exist in.
Well,
Maybe. I just wonder, like, how well it would be able to create an ecosystem for itself in
Hmm.
such a small space. Because, like, it will not, through time, I don't think, like, continue to drill through and make a bigger hole. Like,
Hmm.
I would say it would stay a relatively constant size, and something that you do need, it seems like, for continued life is some sort of cycle there. So I wonder about the ability for a cycle to exist. So not for life to suddenly pop up, but for life to continue existing in that environment.
Yeah.
But I'm
I
sure
think I'm
he's
gonna
also
switch
getting
sides
at.
here though, because now I'm kind of feeling Tryhard's argument.
Yeah, I just feel like too he might be getting at, we're trying to find maybe more complex life than organisms, and I doubt the ability for more complex things, because I would imagine, like, if I'm just thinking about event, like, the biggest it's gonna be is no bigger than, like, I don't know, maybe 3 feet in radius before perhaps the pressures win. Like, for some reason, that's what I'm visualizing here.
Right, but you're visualizing only a singular vent, not what these things generally are, which is like a series of chimneys that can cover large areas of the seafloor. So even if
Mm.
you've only got 3 feet of clearance from a vent to where the nearest ice could possibly exist,
And if we get
you've now got
really
10
into
vents.
it,
That's a
you could
significant amount
have
of area.
you could have
Yeah.
fields of these
Mhm.
things that are 7 miles long.
Right,
Yeah.
exactly.
I feel like too, this is one of the few times where I feel like completely unqualified to comment on this. Like, this is almost something I'd want to email the author and be like,
Absolutely.
hey, so about that comment that you made, like, because
Mhm.
I'm sure there's too, like, further explanation for the existence of
And there's
life that we're not
there's totally a
considering here.
chance he'll get into it later in the book.
Yeah. So, like,
Like, this was just the thing that stuck in my head about, like, but wait, what about this?
yeah,
Oh, interesting.
perhaps it. I don't know. I guess intuitively to me it makes more sense, but I'm not necessarily sure why that's the case. Like, I'm having a hard time putting into words why I'm pretty confident in his claim.
I
Like,
mean,
not that absolutely life can't exist in that environment, but that it is not the place that we should be looking.
When
Fair.
there's not life there, I'm gonna punch a hole in my wall.
Yeah, I'm gonna be so angry.
Yeah.
Um,
I'm gonna be super
Um,
pissed.
but I hate to do this, but moving back to where we were in the book.
yeah, sorry. I
Yeah.
jumped off because I heard my thing, the thing I've been trying to talk about the whole time, and I was like, oh, mine.
Mine.
No,
Something
I'm
that
glad we
struck
went there.
me as
Like
weird.
it's a good delineation.
Yeah, we'll go back to it too as we get there as well. And two, you're right. I wouldn't be surprised if he goes more into it, because it is like literally one of his last comments.
Hmm.
So I wouldn't be surprised if that was more of a, hey, we're going to talk more about this later. The next thing this is one of the things that struck me as weird, is hereafter we'll only consider the case of tidal heating in moons, since that is the most relevant to ocean worlds. And I get that, like, once again, in the same claim that I just made, it's not where you would start. It kind of led me on a thought of, like, okay, he says ocean worlds, it's the most relevant to ocean worlds, meaning that, like, maybe tidal heating of something else is also relevant to ocean worlds. Like, because then I was thinking, I was like, well, what has a strong enough gravitational pull to, like, tidally heat a planet? And I was like, well, a black hole. And I was like, well, a black hole radiates plenty enough heat on its own usually.
Also
Like,
a star, yeah. Like,
also a star. And so then it got me thinking, I was like, is there such a thing as, like, a binary planet system?
I'm
Like,
sure.
imagine 2 Jupiters, like, orbiting each other while also going around, that you can't delineate one as the moon. But then does that cause the same problem where he goes, "We don't get much tidal heating from the moon because of the way it's locked?" Like,
It
you know,
Yeah,
depends on the
the
map.
eccentricity along with the distance between it is the factors of
right,
how
and
hot it gets.
I
But even
imagine
more important than that is
binary
like the mass
planets.
of the two objects.
Mhm.
Yeah.
Yeah.
I imagine binary planets too, on almost all cases, would have, uh, eccentricity of 1. Like, just a fucking circle, because 'cause they're
Mhm.
just, like, circling each other, unless maybe they have moons, it's kind of, like, fucking with it. But
Yeah,
Now you're
too,
getting
like,
really
they had
complicated.
the analogy with the rubber ball, like squeezing a rubber ball.
yeah.
If you just have a static force on the rubber ball, no matter how tough you're squeezing it, if it's one static force, it doesn't actually generate any heat.
Right, and that's what I was saying, like, would it be like the moon and Earth where it doesn't? But that's why I'm wondering, I'm like, is it possible? Like, is that like, I'm not saying this is something we should be looking for, but now I'm just questioning if this is physically possible. Like, is this something that could exist somewhere in the universe where somehow there are two planets of equal size orbiting each other, hence why one can't be called a moon.
I think-
Because otherwise, if one was significantly bigger, it would just be called a moon.
Ace, couldn't you just mock that up in MATLAB?
Like, I don't think I have the necessary physics knowledge
Well,
to mock that up in
These
MATLAB.
I don't
these
have any
planets-
physics knowledge at all. But
These planets are
ultimately, if
orbiting
those
a
two
star, right?
planets are like they are traveling the same path away from the center of the universe at the same speed as all other objects that we can observe, the larger of the two is going to pull the smaller one in. And if it's an eccentric orbit, then it's going to have tidal heating.
But that's what I'm saying. Like, if there's a smaller one, does that just become a moon? Like I'm assuming if there's a smaller one, that's just a moon. And hence, it is exactly the conversation we are having. And I feel like they would have to be within a nearly perfect size of each other for it to count as like a binary planet.
Mm-hmm.
And I'm just really curious. Like, I'm talking about a really, really niche thing here where you have two planets that are binary, like almost the same size. And something about maybe like scenarios I can imagine where they don't have an eccentricity of one would be cases where perhaps there are two larger planets near them messing up their orbits, similar to how like Jupiter bullies all the other planets in our solar system. Where like the main star is still the contributing like orbiter, so it wouldn't like throw them off from each other, but it's just enough to keep them eccentric.
Yeah, if they were kept eccentric, then there could certainly be the argument that they would generate tidal heating.
I don't think they can exist. Is my immediate response, because, or like that after thinking about it for a second there, because at some point all three of them are going to be collinear, and the body farthest from the star is going to be pulled in to the orb, or like pulled towards the closer planet or the central body faster than it would normally when it is in the rest of its orbit. So it is inherently going to like not turn at like a consistent radius. So it couldn't be a perfectly circular orbit.
So you're talking about the moment where they're all like the most
when they're all in a line, because at some point they're going to have to all be in a line, unless the orbit of the two planets was perpendicular to the orbits of the planets around the sun. Unless that is the case.
I mean, if their mass was like close enough.
You see what I'm saying, Ace?
You were giving me like a scenario where I was like, okay, yeah, my initial assumption that this couldn't be real could exist, but now you've given me a way in which I could envision it.
Right. So
possibly somewhere, maybe at one instance in this entire universe existing.
Right. So in general, solar systems are coplanar, where all of the planets end up falling into the same plane and orbiting around their star in the same direction because of collisions.
Which is bullshit.
Which is super dumb and really lame, and I don't like it. But in a world where that didn't happen, you could technically have two planets tumbling like one over the top of the other while rotating around a star. I'm pretty sure that works in my head.
I mean, I see a way that it could work in my head too.
Perfect.
I could even see, like, imagine that their orbits around each other, like, if you were to draw a line, also, like, okay, so, this is really, I need a whiteboard. So, like, say, like, you're at the perspective of Mars, looking at approximately where Earth would be at the sun, right?
Sure, yeah.
That if you were to map out the two orbits, it made almost an X.
Okay, wait, what?
So, like, if you were to map out them orbiting each other, right?
If you were to map out the Earth and the Sun orbiting each other?
No,
Wait.
the two planets. The two planets.
Okay, sorry. Now we're looking at
I
the
think
Orbiting, yeah.
I think she's trying to say like the polar polar
Like
orbit
if you
and
drew
the opposite of a polar orbit would
yeah,
be
so like if you drew a line,
transversal.
if you drew a line from whenever they're collinear with each other, right? And that line doesn't point directly at the sun because they are orbiting one on top of the other.
Mhm.
And there's something about the rate in which that rotation turns that it never points at the sun. It could be coplanar.
Well, no, because there's no
Yeah.
way for it to rotate and never point at the sun.
No, the rate of rotation is kind of like how this moon always points, the same side of the moon is always pointing at the Earth.
Mm-hmm.
Like it is rotating, but it's rotating at such the same rate that it is orbiting. So like I'm saying somehow there's like a spin axis of the two orbits.
So the two planets are rotating so slowly that they are always perpendicular to the sun in that way.
Not even not like perpendicular.
Just like
They don't
facing
have to be
each other.
perpendicular. No, not facing each other. Like the actual planets themselves. That they're so that line, if you drew a line through where they're
Ace,
collinear.
can I have you do me a favor?
Yeah.
Could I have you screen share MS Paint for a second?
I got you. I fucking got you.
Oh,
I
I'm pumped
can
for
do you
this.
one better.
This is what I signed up for.
Yeah, exactly. This is the like I understand this is probably not the most on topic discussion, but I'm here for it.
So I think I get it. So you're saying that
I'm just gonna watch what Ace says so that I don't have like
Yeah,
an
yeah,
extra
wait.
thought in my head.
the
Yeah,
line
don't
for everything.
just wait a second. Don't go down a deeper hole until I explain this. Okay, so you have the sun right here. This is the sun. Do you see the sun?
I do see the
I see
sun.
the
Thank you,
sun.
Ace.
Okay, you're welcome.
Actually, it's like
What it
nighttime
looks
here.
like?
So.
And then that's what the sun looks like. So this is the orbit. Oh dear God.
That's fine. Yeah, it's a circular orbit. I got you.
No,
Orbits
I
are
got
elliptical anyway.
I got this.
Oh hell yeah!
Ooh,
Fancy.
getting fancy with it.
Okay, so if we had like you know how they zoom in on like Hawaii on a US map?
Mhm.
If we had a zoom in here of the planets,
Mm-hmm.
they are orbiting each other.
Mm-hmm.
They're going like this.
Mm-hmm.
And this line in which they are orbiting around is vertical. So like if you were looking sideways at the sun, so this is the plane, right?
Mhm.
They are orbiting not like this, but
Yep.
like it's hard to show you. Like if you were looking at the side, the only time you would see them is like this, and the rest of the time they would be almost more orbiting like this.
Yep. I see what you're saying there.
Circle. So then here, right, if you drew a line through that, their existence, like their possibility of collinearity is pointed that direction, nowhere near the sun.
It's like vertical. It's coming out of the page.
But at the same time that this is also like this line is rotating at the same rate that this is going around. So by the time it gets over here, it's still like this. And by the time it's on this side of the sun, it's still like this.
Wait. So I don't think we're
like they have a bit of a spin to them. It's kind of the same way that the moon always points the same direction. But instead of the moon, it's this line of their spin has a rotation about it. It's got a spin. It's the spin's got a spin, which totally exists, and I know that exists.
Mhm.
And that rate of rotation totally locks up with its rate of rotation around a star.
So basically, what you're describing here is I'm the orbital period of the planet pair around the sun is the same as the orbital period of the two planets around each other. Therefore, the like line or the like collinearity of the two planets never is collinear with the sun. That totally makes sense.
Yes, that's what I was getting at. Great.
Can I now I want to show you like what I was envisioning.
Well, I totally see what you were envisioning as well.
Okay, cool.
I get that as well. I was just like
here's another way to
because you made the mention, you're like, they couldn't be coplanar, and then I was like, no, they could be coplanar. They totally could.
Here, so you have the coplanar solution, and I have the non-coplanar solution. Delightful.
Yeah, basically.
I wonder if that actually works.
I imagine somewhere, at least one instance in the billions of stars in this fucking universe, that happened for at least like a billion years somewhere.
Mm-hmm.
Like, I don't think that would sustain for very long, but long enough that life could exist there, possibly. Like, I just at least one instance. It's possible. It's unlikely, but I think it's possible.
Now I'm pulling out paint just to like mock things up in my head.
Sorry for that divergence.
So what's the sort of next thing that we're looking at here?
The next thing, well, tries doodling on MS.
If there is, I'm not actually sure like what more there is.
Oh, there is. We've got a couple. Well, we've already like talked about them. Like, we probably won't spend as long on them. A small comment I made. Where is this page? Yeah, we're kind of jumping around here. One of the small comments I made is, it says Io is the most volcanically active body in the solar system, even more volcanically active than Earth. And I linked a photo of the volcanoes erupting. I just thought that was cool. And then I was just like, fun fact, Mars scientist here. The biggest volcano in the solar system is on Mars. It's called Olympus Mons. That's all.
One of my favorite quotes from that section.
Mons active?
Huh?
Yeah, my favorite quote from it was saying that like Io is erupting like right now.
Yeah, I love it.
Like, it's so volcanically active. There's no atmosphere. Well, there's no atmosphere is another thing, but yeah.
And then Rada liked the comment, tidal heating generates 2,400 watts per meter squared on Io's surface, over 1,000 watts more than the oncoming solar energy flux received by the Earth, and nearly equal to the 2,600 watts per meter squared that Venus gets from the sun.
Yeah.
That's a lot of energy.
Very cool stuff.
It's a lot of energy, but that's a comment, that's a quote that Rada liked.
Yeah, I like that. It's an interesting scale to think of it on.
Yeah.
It just shows how powerful tidal heating can really be.
Yeah. My next comment here that I was flabbergasted. A relatively thin ice shell, a few kilometers thick to as much as 30 kilometers thick. I'm sorry. A relatively thin ice shell is 30 kilometers? Like, what is thick? I need to know what.
Well, it's definitely
relative to what exactly?
It's relative to the ocean of Europa.
Oh, because I literally wrote here, I was like, if 30 kilometers is thin, what the fuck counts as thick?
I don't actually remember. What was the figure of like how deep Europa is?
100 kilometers.
100 kilometers? Okay.
So it's a third. Not a third.
That's still a lot. What?
It's not quite a third, but it's pretty much a third. Like, that's still like not a thin ice shell to me, in my opinion. So like, are they talking relative to like they built some model on planet like water worlds like this existing, and relative to that it's thin?
That was the question I was going to ask.
Yeah, that's kind of what I was getting at with my question too. Like, what is it relative to? What is making 30 kilometers thin? I need to know.
I think it's relative to the amount of liquid beneath it. Sorry.
I think it might be relative to, like other ice worlds where like they don't have tidal heating, where like maybe all the water is just, all ice.
Yeah. Rada also commented on this. On literally the same quote. He said, "This is super interesting to me. I need all the scientific sources you have about this. Period. Now. Period. Please. Period." And I have no sources for this. I don't know.
Seems like he's serious about it.
He was serious. But that was my slight muse, which I'll probably dive into it more, and we can talk about that more next time if I find anything. totally got distracted and didn't do it this week.
Hmm.
Laplace resonance, that shit's cool.
Mm-hmm.
That was my only comment there.
Oh yeah, this sort of ratio of them making their orbits eccentric just by the virtue of like them existing and orbiting sort of around each
Yeah,
other,
like them
exerting their
pulling on
own
each
orbit.
other. Yeah,
Yeah.
love that. Super cool.
I think
Um,
it's a matter of them maintaining their eccentricity by virtue of their own interaction.
Yeah.
yeah, that's fair. Another one I really enjoyed here that I didn't write down, but they were talking about Laplace factors and how eventually it will probably go and like how long it goes. And he says, such as tidal energy dissipation or how Jupiter itself responds to the interaction. And I jokingly mused, perhaps Jupiter will become jealous.
Try to form
Jupiter
its
is a
own Laplace
bully.
resonation, am I right?
I would argue that Jupiter is one of the most personified planets in our solar system. Like he's in like planetary science, he's constantly referred to as a he, and that he's one big bully, and that he bullies like Mars's oh shit, what's the word? Mars's
Orbit?
basically tilt. No, tilt.
Oh.
The obliquity, that's the word I was looking for. The obliquity or the
Doesn't its
tilt of the
orbit kind
planet.
of like just go all around the place?
Its orbit
Mars's?
changes a lot, and then its obliquity is like super chaotic.
What is an obliquity?
Obliquity is so kind of the reason we have seasons. So Earth sits at a tilt that is 23.5 degrees.
Yes.
And obliquity is the fancy word for that. And Mars's obliquity changes. It doesn't stay constant. Like we have a nice moon there that kind of helps us stay constant. When you don't have a big moon and you have a big bully next door, it goes anywhere from 0. I think the max that they've modeled is 70 degrees, like almost completely sideways. Because as the personified Jupiter is a big bad bully.
So how exactly does Jupiter tilt Mars so much?
It's gravity.
Pulls on it.
Just as that much gravity?
Yes.
God.
It's a big bad bully. Also, my probably favorite quote in this whole fucking section, which Rada also pointed out. Years ago, my PhD advisor, Chris Chiba, liked to articulate this point by saying, Earth is a bad place for life. That is, for all the spectacular abundance of life on our planet, the raw materials to create it are actually hard to come by.
Yeah.
And I wrote, now that is food for thought.
Mm-hmm.
Yeah. I think
that
was my favorite section.
Like, this is the one that I was kind of talking about earlier, that quote and that idea makes the thought that we might be alone in this universe like so hard to believe.
Mm-hmm.
Like I've never really believed that, but I've also never been so convicted in that thought, especially now, that we are not alone. Like I am very convicted in the fact that we are not alone in this universe, and that only made it stronger.
I agree 100%. The thing I would say is that it's possible that we may be alone in consciousness.
Yes,
because
agree.
Like microorganisms or like single cell organisms and stuff like that are ubiquitous on our world, and they could be dominant species on any number of worlds.
Yeah. But have you ever heard of the Fermi paradox?
Fermi paradox.
I have not.
This actually relates to the likelihood for consciousness outside of Earth. Let me see if I can pull it up and read it word for word. If not, I will do my best at butchering re-explaining it.
Just drop a link in the Discord too.
I mean,
like, well, there's a great short statement that like explains it. No, leave me alone. No.
It's basically just the disparity between the enormity of the universe and its emptiness. That's like it in 2 words. It's basically there's a whole lot of space out there where a lot of shit should be happening and nothing's happening.
Yeah,
I mean, there's a lot of space between like your own cells and stuff's happening there.
Yeah.
Like, I think it's just a matter of people would expect to have seen things by now, or like
Hold on.
it would.
There,
Ace will pull it up.
Man,
there's still
that's
one
so,
really.
like,
Oh,
Terracentric.
here. Okay, I think I found the the quote here. Maybe I should just read this. That might be easier. Okay, so as many stars as there are in the galaxy, 100 to 400 billion, there are roughly an equal number of galaxies in the observable universe. So for every star in the colossal Milky Way, there's a whole galaxy out there. Together, that comes out to the typical quoted range between 10 to the 22 and 10 to the 24 total stars in our observable universe. Which means that for every grain of sand on every beach on Earth, there are 10,000 stars. So if you picked up a grain of sand, that's 10,000 stars. So then, this isn't totally in agreement, but a ballpark quote of what percentage of those stars are sun-like typically ranges from 5% to 20%. If we take the lower end of that 5%, that gives us 500 quintillion or 500 billion sun-like stars. So then there's
That's
debate
just
over
stars in that particular age.
in the sun-like in size, temperature, and luminosity.
Okay.
So then there's also a debate about which of those sun-like stars might be orbited by an Earth-like planet. So we're not even talking about tidal heating at this point. We're only talking about the original Goldilocks zone. Some say it's as high as 50%, but we're going to go with the conservative 22% that recently came out. So that suggests that there's a potentially habitable Earth-like planet orbiting at least 1% of the total stars in the universe, which is a total of 100 billion Earth-like planets. So there are 100 Earth-like planets for every grain of sand in the world. 100! Like, you pick up a grain of sand, that's 100 Earth-like planets in this universe. So then from here on out is where it gets, like, super speculative, right? So say 1% of Earth-like planets develop life. If that's true, every grain of sand would represent one planet with life on it. And imagine on that 1% of those planets, the life advances to an intelligent level like it did here on Earth. That would mean that there are 10 quadrillion or 10 billion intelligent civilizations in the observable universe. So the question is, where is everybody? That's the Fermi paradox. Is like, you take this really big number and you take the lower end estimates for the possibility of these things happening, right? And apply that to that total number of stars. It is still comes out to be about 10 million billion intelligent civilizations in the observable universe.
And the whole argument that why haven't they reached us is probably because they're probably like us and don't give a shit about space.
Well, that's the paradox part. Like, that's one of the explanation, but there's several, like, common explanations that could be, we're early, we're late, like, we're special in that the timing that our intelligent life existed. Like, yes, the aliens did build the pyramids and then they went fucking extinct. Like, I don't know. Or just we're in the quiet side. We're in the far reaches to them. They're all on the other side. Like, we already know how hard it is to traverse the Milky Way in Elite Dangerous.
Yeah, first of
now
all,
imagine they're on the other side of the universe, right? And that's the, like, really teeming with life. Like, that's Star Wars. That's the Marvel Star-Lord universe side. And we're just over here like, hey guys.
I just want to come out and say, like, everybody can quote me on this. Fuck you, Sagittarius, for flinging us way the fuck out here. With a fucking spiral arm. That's bullshit.
It's bullshit.
Yeah.
But, like, so that's one of the explanations. One of the, like, more dim explanations is intelligent life is just that fucking rare. And then one of the ones is just, like, it's too short of a time period that intelligent life exists. So, like, they pull up once again the cosmic calendar and show, like, the length of time between the T-Rex extinction and the present day, which was fucking forever ago, and like just
Man, I
how
can't
small of a
buy
blip
that.
that is.
I
Or
can't buy
maybe
it.
they're type 1 civilizations. Like, I just don't buy it either. Like, they're out there, but like, where are they? This is the paradox.
Yeah, to me, I wonder if, the sort of, what, I don't know exactly what you call it, like hyperspace, going faster than the speed of light. I sort of question if that's possible. Like, if it is possible, wouldn't there be like aliens right here?
I mean, it doesn't
Or
need.
maybe we are early and it's just
Yeah.
still in this universe hasn't existed yet. One of the other common thoughts is that, like, say we actually reach a more intelligent civilization ourselves, right? And we come across a planet teeming with life. And the best they've got right now is radio signals coming out, and you're about to land on their planet and communicate to them that you can go faster than the speed of light and that their universe and their gods that they have made up aren't real. Like, or that they're not special like they thought they were. Like, that might destroy people, So maybe they have some level of humanity to them, and they are here. And they're just patiently waiting for us to catch up to a level where they think it's acceptable
They
to
might have.
intervene.
I mean, they might have seen us split the atom and use that to kill 100,000 people.
That too.
in a
Like,
moment.
maybe they saw us and they were like, these fuckers are hostile and a little bit primitive, and we're about to show them like some real technologically advanced stuff. I want nothing to do with that.
If you
Or
guys
it could just be like studying us as well.
If you guys are
Yeah.
interested about
Also
the whole
true.
Fermi paradox thing, this is a YouTuber that I encourage everyone to like watch if you guys enjoy space. But this is it's a whole compendium of all of the common theories about what, like, explanations for the Fermi paradox, and they're not. He doesn't like pick one. He doesn't say, "Oh, this is clearly the right answer," but like he lists all of the possible solutions. He has a whole series on it, but this is the video that goes over the whole breadth of the possible solutions.
So this is the Fermi Paradox Compendium by Isaac Arthur.
Indeed.
Um,
Oh, right. We're
yeah,
recording.
we are. Yeah, like, too, and what I was continuing is kind of like when you go to like a wildlife reserve, do not feed the animals. They try not to intervene and help the animals if it was their time to like die, like trying to leave it as natural as possible. What if there's some like intergalactic agency that's like, do not talk to the fucking Earthlings, do not feed them, do not let them become dependent on you, like
God.
they can't handle it, they're fucking ants. Or what if they're like fourth dimensional beings and they really can't, they can see us, but we can't see them because they're just living in a plane of existence that we can't comprehend. Like, ouch, but like, sure.
Look, I get it. The cure to all diseases is it's just normal for you, but don't give it to them because it's
Don't
going
give
to
it to
screw them
them.
up.
Right, but there's
They
the
gotta earn it.
issue with any of those solutions is just assuming that all of the all aliens would follow that, even if it was the law. Like, even if it's
Right,
the
yeah.
greatest rule, you're telling me that an intergalactic society of likely trillions of individuals, all of them are going to follow that rule?
Right,
just-
but it almost feels just as unfucking likely that like there's that much possibility for intelligent life
Well,
that hasn't contacted us in any way, shape, or form. Like that
let's
still
let's
feels
be
equally
real.
unlikely.
Earth is unremarkable. Like there's not a
Yeah.
lot going on here other than us, and we think we're remarkable. But
Or similar to how they say Earth is a bad place for life. Like they may
yes,
not even be looking for us here because
that
the
was the quote
likelihood
I
that
was
we exist,
trying to remember. Yeah.
yeah, the likelihood that we should exist here is low. Which would also be a sad thought. Just kind of abandoned out here, just floating on a rock. No one cares about us, but like whatever, fine.
Yeah, but we have fucking candy.
Fucking candy.
Yeah.
And
You can have
podcasts.
that. So that's
And
pretty dope.
and like Apple Watches. So get fucked, aliens.
Get fucked, Apple.
Get fucked, Apple. Rada chimed in on this whole Earth is bad for life by saying, if Earth is that bad for life and human evolution on Earth, is there a potential for us adapting to a better place for life? You know, like, is there somewhere far more better and advantageous to the human life to live?
I
I
mean,
think is where he was going
That
with
sounds
that.
pretty cool to me.
ancient Earth was better for life.
But the creation of Earth, like what they're getting at in this book is the creation for Earth was never good for life. Like the limited resources to begin with.
I mean, if you go back to like the Jurassic period or the
Mhm.
265 million or whatever,
yeah.
like we had way more oxygen.
Right, but I think in total, like,
organisms- Go ahead.
Like we're talking about the formation of Earth times, like the chemicals that were involved in the formation of Earth
Oh
are
yeah.
so low in comparison to like outside the frost line
Yes.
and to other planets too inside the frost line. Like we are just remarkably lacking in the things that seem to be important for life. Even in the dinosaur era, which is why it's kind of so mind-blowing that we even exist here.
I mean, we are the mutant result of an apocalypse.
Yeah. So then Rada's here saying, you know, is there potential in our future for adapting to a good place for life? Which I totally think so. And ideally it'd be like fucking Superman, you know? Like he grew up in a place even worse for life and then he came here and is basically a superhero. Like sounds pretty prime to me. But yeah, I think that's an interesting thought. Moving on, we're nearly done.
Yeah.
Which-
Should I get this wrapped up in a little bit? Because we are near that 3-hour mark.
yeah.
Yeah, we got some time. It's fine. It's fine.
Yeah.
I said that as a joke.
No, I think it's a reasonable limit, though. Like,
Yeah,
expecting
3 hours.
anybody to catch up on a 5-hour book club is probably not ideal.
Not great.
Yeah.
The next quick thing that I commented on here, we're on page 43 now.
Okay.
Has like all the different moons.
Mhm.
Almost here. Vigorous water-rock interaction, which we briefly talked about. I just thought that was interesting that is a requirement. And then I started musing about the fact that is there just like a blob of water floating out there? Does that count as a planet? Like, is there
So-
just like a gravitational blob of liquid water just hanging
So-
out?
This is funny because this is what I thought these ocean worlds were. I had never thought about it, but I was like, oh yeah, I know that there's an ice shell and there's some water in there. It had never occurred to me there was a rock in the middle of the water.
Well, so there
I
can't
thought they
be,
were just
like, a
big ice
blob.
bubbles.
But
There
do
can't be
big
a
ice
blob.
bubbles exist?
I mean,
I
there
mean,
could
yeah,
be.
they can, and I think they mentioned like a world that was basically mostly water, or a moon. I can't remember too well.
But they say
But
mostly, they don't say all. I need to know, is there all? Does that count as a planet, or is that just an amorphous sphere of water that just happens to be orbiting something? Will that eventually be destroyed for some reason or another?
I don't know.
I
Like,
don't know
is
if
the
that would
rock
be able to
core
like stay
necessary?
together though. I think it would have to have rocks so that it would be able to have a gravitational force, maybe.
You know what I bet the issue is?
Hmm.
I bet any liquid body would be distorted so much by any gravitational force. Like
Well, you know
any,
what?
like the tidal, the same tidal effect he's talking about here, where you're deforming it. I bet it wouldn't have enough structure to hold itself together, and the ice shell would crack. That would be
Well,
my.
I also wonder, you know, by the time that you have it warm enough for liquid, you either have to, one, be close enough, as far as we know, close enough to a star, which I think at that point, whatever star it is does have too much gravitational potential over something as light as water compared to
Mhm.
rocks.
Yeah.
And so then it would just be pulled in. But say it was like tidal and it had like an ice shell on the outside, you know, like maybe it is just still like for it to be that warm, it has to be denser than like just liquid water. Like it has to be denser to maintain an orbit and actually count as a planet and not just immediately dissipate or like you said, like crack and become an amorphous blob and like split apart and like not have enough like gravitational potential to keep itself in. And like I imagine that the center of one of these worlds would have to be super ionic ice. Like it would have to be like a pressure ice at the center. Like
Yeah, it
mean,
has to have
something
depending
solid.
depending on
some
its radius.
solid to be in the
But
middle.
it's an interesting thought. Like, could you imagine just coming across that? Like, you kind of how like the fucking astronauts like put little water bubbles in the space station. And you just like you're out in space and you look over and you're like, what the fuck? It's just one giant big water bubble. Like, how neat. I
Mhm.
don't think it's possible for some reason, but cool.
Cool.
Any other comments on that?
No.
Cool.
I mean, intuitively, it doesn't seem right that you could just have like a blob of water just floating around in space without something keeping it together, even if like that is like ionic ice. Like that doesn't seem right to me.
Yeah, it seems like water is just picky enough for being liquid. Like I could believe there's a big I mean there literally are big ice chunks orbiting. Those are called comets. Like
Yeah.
that totally exists. And I just imagine too that I don't think liquid water could just be oh, duh, that's the answer. Liquid water needs some sort of atmosphere to exist. Really. In almost all cases that liquid water exists, there is
Because the
some sort of
vapor pressure of a
atmosphere.
vacuum is
Yeah, and so the vapor pressure would just boil it away. Never mind. That answered my question. Now I'm sad
Oh.
because now an amorphous blob of water can't just exist in space, but like whatever, it's fine. I'll get over it. Yay! On to Try's comment that we kind of diverged to anyways.
So we've already diverged to it, so I'll keep it really short. But basically, I was just questioning like basically ice at the bottom of an ocean, how that would realistically work, and then we discussed whether or not hydrothermal vents would be hot enough to melt the ice. And I don't know if you guys saw, if you scroll up in the chat a little bit, I put in a tri-point chart for water with some temperatures and some pressures on it. And at the bottom of the ocean, like at the bottom of the Mariana Trench, we're looking at a little over 1,000 bar. So if we're talking about 2 times 1,000 bar, we're somewhere up in the 2,000 bar range. You guys can see what the temperatures required for that.
For it to be liquid or solid?
So you can look at it. Basically, it would need to be. Sorry. We're talking about 2,000 bar for the what was it? I think it was the large when it talked about the planets that were too large. It said that some of them would have twice the pressure of the Earth's ocean, so that would be about 2,000 bar. Again, that's a rough number.
Mm-hmm.
And that would require it to be somewhere here in the
250 Kelvin.
Yeah, 250 Kelvin for it to be liquid. And then I looked up. It looks like it's about 400 C is the peak temperature of hydrothermal vents, which is way over here on the rightmost boundary of the chart. So it looks like there could definitely be liquid around the vents for some distance.
Yeah, but the other point I see here too is like it says up to 2 times as far as we know.
Mhm.
But I would say it's also completely physically possible for moons to exist with a gravity greater than so basically 100,000 bar is about where that turns solid almost no matter what.
Absolutely, yeah.
And that totally seems also plausible if you have way more water, way bigger ocean, way more gravitational pull because for some reason the core is denser, you know?
Absolutely, and I completely agree. It's just a matter of like it sounds like it would also be possible for there to be an ice and then thermal vent heated like little pocket under that even subsurface ice.
I think
Yeah.
I think in that scenario it would just be like expelling sublimated vapor.
I'm not sure I know what you mean.
Well, you know what sublimation like
Mhm.
what a So it would expel the like
Whatever's coming out of the thermal vents.
right. So the vent would be expelling solids that immediately sublimate.
I think it would still likely be expelling. Oh, that's interesting because it might not be. Huh. That's interesting. I hadn't thought about what a hydrothermal vent would look like under that much pressure. I don't know. Interesting.
Yeah, like does a hydrothermal vent operate under
Under that much pressure. Yeah.
And like you'd have to look at the phase diagram too of the gases coming out of the hydrothermal vent.
Yeah, definitely do not count this as like somebody who knows it. I'm just.
Oh no, it was an interesting thought for sure. And then I don't know, Ace, if you want to look, but I just drew a little thing on the stream.
Watch stream. Yeah, I had you on that one.
So well, this is the diagram you drew, right?
Yeah.
And I think if you like imagine these vectors here, like this angle, you can see my cursor, yeah?
Yeah.
This angle is going to stay the same in relationship to the sun at all times.
Yeah.
Under your example, which means that the sun is pulling on the orbit in the same direction at all times, which is going to squish this orbit like along this angle. So it's going to become eventually like, for example, let's see here. Let me give up. Do I have a? I don't
But like, I feel like that's also a really extreme example. Whereas it could just be like not as extremely away from it, and one of those could be like the back one, or
because no matter what it's doing, if you look, the vector on this planet is like, oh god, I can't. Do I not have an angled one? Well, the vector on this planet is.
I don't think it would permanently squish it over a super long time. I think it might actually just create eccentricity that allows you to keep it right, because then as one goes away, it suddenly loses that pull and pulls in shorter or faster. And then as it comes in closer, it gets pulled again further away. Like, I feel like that might just breed an eccentric orbit.
But like if you look at where the vectors are pulling, it's definitely pulling it. This planet isn't going to be able to make it around. Like this back planet is not going to come across the top here because it's not being pulled.
You don't necessarily know that though. Like that totally depends on the rotational energy that they were given when those planets formed.
Right, but it's gonna be dampened so dramatically by the sun unless.
But I'm saying you don't, like, I would say that's not as like physics wise. I would say that it's not necessarily true that it is that dampened by the sun. Like
it is if the two planets are of the same size and are having equal pull on each other. The sun is going to throw that out of whack so quickly. I don't think that's stable at all.
But I feel like that's not accounting for if that sun has a weaker gravitational pull than, say, our own sun, how far away those are. And I still counteract with the amount of rotational energy that they were created with, because it wants to stay, right? Because that's fucking Newton's laws. Like, it wants to keep that rotational energy more than it wants to give to the sun's gravitational pull. And like certainly it would over time, but we're talking about a time scale for life to at least exist for a period of time, which I feel like is absolutely possible, because under the guise that Earth didn't used to be in its orbit where it is today. Like those move plenty of times. Like I feel like there's a time scale, a rotational energy that goes into this that exists in which this could still exist for some period of time. Like, do I think it would sustain? Like, as long as something like Earth's orbit would sustain? No. But do I think it would sustain long enough for something to exist on it? Yes.
Okay.
In like a rare circumstance. Like, I'm not saying this is even like likely going to happen in our universe. Like, it would have to be such a rare circumstance.
Gotcha.
But I'm saying I think there is a method in which this is physically possible, that you could model this and it would work. And if I knew more about physics, I'd fucking get on it.
Okay.
Trying to model this. Right?
Yeah, I'm still not sold on it, like at all.
Oh boy.
But that's okay. We can move on to whatever's next.
Well, I mean, we're just on to your comment.
Oh yeah, I mean, I feel like we talked about my comment already.
Yeah, other than that, I'm not sure
Oh, I see. Yes, I have written the last comment. Look at me go.
you have written the last comment.
Typical.
Yeah.
Typical. I don't think I had anything else. So,
What are we reading next time?
yes, this is important.
Ms.
So, we will be starting into part 2, going into the Rainbow Connection, and
Me.
ending with the end of chapter 5. So, do not read chapter 6.
Perfect.
We'll be reading. No, we're going to be reading chapters 3, 4, and 5, which is pages 49 to page 95. So about 50 pages this time instead of 40.
Full.
And I imagine it will be a bit more dense this time as well. So I would prepare a little extra time. And kind of like how we went through the comments on the doc today, even stealth, if you're self-conscious about putting comments, you should definitely put comments in the doc, so it's not just. I feel bad if I'm just the only one like leading us through most of the discussion.
I think I got a better sense of what you would like, or like what can go in the doc today. I think
Gotcha.
Yeah.
I think it
Yeah.
was a lot more. I think the bar was not necessarily lower, but it was just like more broad than I realized. I had like a specific thing in mind that I wanted to talk about. Like this was the single most interesting thing to me, and I was like, okay, this is the thing that I have brought to the group, and it was like a discussion that I was ready to have. Versus like, you know, some of yours are literally like, man, I really liked how he said that, and it's like, oh, okay, that's very different than what I thought we were looking for. So I think I personally, at least, will feel a lot more comfortable just throwing like, oh yeah, this was fun.
Yeah,
For
like it could
me,
even. Sorry, go ahead.
for me, it was more of a problem of like time management. I feel a little bit bad about this. I ended up finishing the reading roughly 20 minutes before we started talking.
Woo!
So yeah,
That's fair.
I too have been in high school.
yeah. That I almost failed English 4 times in a row. So
Ooh,
thumbs up.
thumbs up.
Wait. And this isn't a judgment. This is just a question about the words you said. Did you almost fail English 4 times, or did you fail English 3 times in a row and almost a 4th?
Oh, almost
Seems
failed
like you can't
4
read
times
English 'cause he said it in
consecutively.
8th grade.
Gotcha. Okay.
So like you took 4 English classes
Yes, and
and
got
almost failed every.
a D/C every single time. It was almost wholly a problem with me not submitting essays.
Mm-hmm.
Ooh. But yeah, so as far as comments, it could literally be like you catch yourself stopping and perusing about something, slap it in there. Or it could just be like, that's kind of why I threw in the quotes we enjoyed. It could literally be like, I like the way he said that.
Yeah. My plan was to read it all, and then I would go back through it a little like more quickly and kind of pick out a couple things.
I didn't know we could do that.
Sorry.
What, read it again?
Just read the whole thing.
Oh, not the
Oh
book.
no,
No,
the
whole
whole
section.
section that we were assigned.
Oh, see, yeah, this is bullshit.
I kind of like held off putting a lot of my comments in because I didn't want it to seem like you guys were getting on in anything you thought was already there, but I'm glad that didn't seem like that's what was stopping anyone.
Yeah. No.
Totally
fine.
So I'll probably just continue posting my actual pace. And what we can do is if there's already a comment there that you agree with, just put a colored X behind it. Like basically saying, yes, I'm also interested in that. So maybe in the future, especially if you guys are going to start adding comments, we have way more to get through. We can choose the most like agreed upon interesting things. And then we can go back and go over like the weird little like I liked this comments that I made just because I was trying to invoke more discussion. But yeah, this was great. I had fun. I enjoyed
Yeah.
debating about science and orbits and whether they're possible because I feel like I'm just unqualified enough that I can bullshit anything. Um,
One
and
thing
then
I
on
do want to bring up is that 2 times in this we went over a diagram that the people listening won't see. So if you could like upload that to the channel,
yeah, I'll upload to the yeah.
or
I
maybe as
think
like a link on the video, perhaps.
I think my plan in the future is probably to just screen capture the entire thing, especially because this audio recording device didn't seem particularly great. I'm just on my
Yeah,
laptop in another state right now, so that didn't seem, like, plausible to set up on my laptop.
That's fair.
fair
Um,
enough.
but in the future, I will probably just try and find, like, a really pretty way to present our comments here, and then almost, like, screen record it so that there's visual things to look at, and if anyone's streaming anything,
Mhm.
and just, like, make it a video as well. So at least
Yeah,
someone could look up and read what we're talking about again. Um, and then I'll upload this on YouTube. I'll look into what it takes putting it on Spotify. I don't know how hard that is because that would also probably be useful for people.
There will be a lot of people who read this book eventually, and I think having something like this available will probably be pretty useful.
Yeah, I think so too. I think I've never heard of like a book club thing on YouTube, but I'm sure it's a thing.
Yeah, it definitely is.
And yeah, like I bet there's like some people into this. I'm just not sure if it will catch on about a book like this and a whole bunch of people who aren't super qualified to be talking about it.
No, no,
But
no.
maybe that's the
Ace,
selling
Ace,
point.
Ace. This is the
But
internet. It's all about people who aren't qualified to talk about things. That's the whole
What are you
point.
talking about? I looked up at the sky once.
that's fair. So then in terms of like formatting for this too, I'm gonna ask that like most of the comments that we go over either be like X'd out or commented at least an hour before we meet. So then I can sit there and like kind of make a game plan for the discussion next time. So maybe it's not 3 hours, maybe it's two.
No, I
yeah.
realize
Have
it's
some
kind of
Um,
have some
rambly and
vague sense
meandering.
of schedule that we can kind of follow, so that there were a lot of times where we got into like very very specific discussions,
Mhm.
yeah, I feel like
um,
they were
which
interesting,
are
but it
good,
would be yeah. Um,
but it is something to think about.
yeah, I also had to, like, sit here and scroll back and forth and make sure I was hitting all the, like, number points, so if everyone can get, like, comments and, like, their little signature X's in and at least an hour before so I can sit and, like, organize them and kind of make a game plan before, that would be super great. If you do get it in after the hour, that's fine, we might not get to it or talk about it. Unless it's, like, super pertinent, then just bring it up and, like, leave a note for yourself. Let's see what else. Page numbers first. We decided to do page numbers first. Totally
Mhm.
Yeah,
reasonable.
Yeah.
And then the quotes we enjoy, just start the numbering over at 1 for your color. So I'll just have an easier time making sure that if you referenced something, I can just look at your colored number, if that makes sense.
Yep.
So then when I go to, like, reorder them, it doesn't reorder the actual numbering.
Loud and clear.
Loud and
Sounds good.
clear. Other than that, sorry for the 30-minute delay today. I feel like Dad's birthday was a reasonable excuse.
I mean, I'm just glad you could make it all the way from Utah.
Woo!
let's go.
We're here, we're here.
Solid effort.
Solid effort. Maximum effort. So yeah, and more people are getting the actual book now too, Rainbow and Rada.
Yeah,
So
I should be getting it tomorrow.
I ordered
um,
the audiobook off Audible. I had like a butt ton of credits that I forgot about, so
Nice.
solid. So I don't
Actually,
know. Oh, go
I
ahead.
really enjoyed the audiobook, or at least as much of it as I've heard.
it's quite
He,
good.
yeah, he does a really good job of,
I might have to listen to
I
it.
think, expressing his passion for it.
And I think something
Hmm.
else that, at least for me, is really helpful is I listen to it twice. I listen to it once at normal speed, and then I listen to it once at double speed to go back through and like try and think about it again and find the things that stuck out to me.
Yeah.
Ooh, smart.
I thought that was very helpful because at double speed, you only really hear the stuff that sticks out.
Yeah, that's fair. I don't know if you guys would be interested in this too, but to hopefully not make it a time crunch at Rainbow. No, I'm kidding.
Yeah,
I could
I'm
I
definitely
could
gonna
kind of
try. Yeah,
Rude.
I could kind of make a bit of a schedule if you wanted, like finish these pages by then and make these comments by then. And if you're interested in that, I can totally throw that together.
Everybody do one chapter every 2 days.
Basically, yeah. Try and stick to that schedule.
I mean, yeah. I've definitely been sticking to like a chapter at a time, which is helpful for me. Like,
hmm
but my schedule is basically like the past 3 days, just because I procrastinated.
That's fair. So yeah, let's just try and get more comments in next time. Woo! And then hopefully the future like discussions will be
Yeah, just have a more productive discussion.
not only more productive, but I felt like it was kind of one-sided because 99% of the comments on the page were me this time. So
Yeah.
I felt like I felt bad because it kind of seemed one-sided, but I also didn't know where to go with everyone else except present topic and then wait for
I thought it was
interaction.
good though. I felt like
Yeah.
even though they were your original like notes, I feel like everybody clearly like had something to say about them, which was good.
That's good. I tried to I definitely made way more notes than that and just tried to pull out the ones I was like, this seems like something everyone can discuss.
Yeah. Well, I think also myself personally, I don't value what I am seeing in the book as much, and having other people post things that they want to talk about, I can get involved in those things. If that
That's
makes any
fair.
sense.
Yeah, that totally makes sense. Still, I encourage you to make at least one per chapter.
Yeah, I
Well, yeah,
definitely
we
want to
got
put more
uh,
work into this than I did this week,
Yeah,
because I really
let's
enjoy it.
All right.
Yeah, I
Are we
really
done? Can I go listen to chapters 3 through 10?
Yeah, that's
no.
the thing.
You can listen
wanna
to 3
go.
through 5.
Are you sure?
Yes, I am sure. Come on.
3 through 5.
We even accidentally skipped to like comments at the very end of this section, like halfway through. So don't read past 5. Don't read chapter 6.
I'm gonna do that.
So don't read chapter 6. Just listen to it. Gotcha.
No.
No, yep, no, he's right on. I'm agreeing.
Okay, well, for anyone possibly listening, if we really want to wrap this up, for anyone possibly listening, thank you for listening to our nonsense for 3 fucking hours. I don't know why you would choose to do this, but I appreciate it.
Like and subscribe.
Like and subscribe because this
Yeah,
is becoming a
smash that
YouTube
like
channel
button.
now. Smash,
Hit that
smash
bell
like
to become
button.
part of the alert squad.
Sometimes YouTube just like unsubscribes you, so double check that you're actually subscribed and turn on that bell if you want notifications every
Did you
time
know
we
that
upload.
0% of the people who are subscribed at this moment
can
are
we
listening?
stop this?
No.
This kind of sucks.
All right.
But I'm trying to build my brand here. Give me a break.
Yeah, come on. Anyways, yeah, thanks everyone for coming to book club this week. I can't wait for book club next week. Oh, and last note, I made a new channel called Related Links and Articles.
Yeah, I saw that.
For furthering.
Oh, hey, before everybody disperses, can we
Yeah.
talk about Ceres for a second?
Talk about
So what?
what?
Ceres, the one in the belt.
The moon?
Oh,
Yeah.
Or a
Ceres?
planet? Or a dwarf planet, I think.
Is Ceres not the name?
Ceres?
That
Yeah.
is- Yeah.
It's like
Yeah. So
Yes.
there's liquid, maybe.
What?
Anyone?
What are you talking about?
I mean,
So
maybe,
okay,
I
so
don't
there's
know.
a what do you call them?
Exoplanet.
Planet. Yeah. Well, no, it's not exo. It's in the asteroid belt.
Okay, yeah.
Yeah,
But
I know what
it's supposed to
Ceres is.
liquid on the inside now.
Okay.
I do
Oh, is
remember
this
it
like a
mentioning it.
recent report? It literally happened a
I don't
day
know.
ago. What? Oh, look at that. Water on dwarf planet Ceres could help us search for extraterrestrial life. Dwarf planet Ceres has a quote-unquote ancient ocean with salt water, researchers confirm. Okay, what researchers confirm? Hold on. Hold up.
Well,
Hold,
obviously, it's the dudes
please.
that are way out there doing it. Just
See,
fucking.
here's interesting. Claims of ocean inside Ceres may not hold water.
Um,
I appreciate
Occupator
the pun.
crater, where scientists believe an ocean of salt water. What? Researchers discovered. I'm like, they didn't discover, they're musing, okay? 7 different research papers in Nature Communications. Nature. Oh my god, it got published in Nature. What?
I feel like I'm just gonna head out.
Oh, it's below the surface.
It's
Yeah.
subsurface water.
I'll do more research on this and bring it next week.
Dope.
Yeah.
I just
All
read
right.
about it today. I didn't mean to.
No, I
No,
agree.
that's exciting. It's like totally on topic.
It's a last minute thought, but we're good.
Last minute, but I'm gonna do some research. We'll start with that next book club. A little interesting scientific article note. Some
All right.
in the news.
Oh,
Um,
nice. No, I got
Oh,
that
dude.
again.
Can we have in the news corner? Can we have a corner in our podcast? It'll be great.
Yes,
yeah, in the news
I
corner.
agree.
And then I'll go find the actual articles themselves instead of relying on things like Fox News to tell me what's on that
All right,
planet.
I love you all. I got a phone call
Yeah.
coming in.
All right.
Yeah,
Bye,
yeah.
guys.
Next one.
Okay, bye,
y'all.
bye,
All
bye,
right,
bye.
see ya.
Everyone leave. Goodbye.